Hey, this is Juan Tutors, and today we are doing the June 2024 Algebra 2 Regents. This Regents literally just happened a couple of weeks ago, and I'm really excited to do this Regents with you guys. I'm going to go over every single question that's on this Regents. But not only am I doing every single question, I'm going to give you hints on how to get your best score, how to do what happens if you don't get to a problem that you don't know how to do and you need to do some process of elimination. I'm going to do all of that. I'm going to do all of that. My goal is to actually make the GOAT of all Algebra 2 Regents videos in this video. So if you feel like this video is the GOAT of all Algebra 2 Regents videos, tell me that this is the GOAT. This is the GOAT of all videos. Just tell me that in the comments. But there's a few points that I want to make in the first page that are really important, but I'm gonna put those into the test along as I'm doing problems. This is the formula sheet at the end of the test, and I'm actually also going to talk about that while I'm doing problems. But right now, we're actually just going to get right into it. This is the part one of the Algebra 2 Regents. Big important thing, in your raw score, each correct answer will receive 2 credits. So if you get the question right, you receive 2 credits, and then that gets converted into a scaled score after you're done with the whole test. So do remember that number, 2 credits. That's actually really important in terms of test taking strategy. But right now we're going to get right onto problem number one, numero uno, which expression is equivalent to x plus 3 squared plus 4x plus 3 minus 5? Is it x plus 5x minus 1, x plus 8x plus 2, x plus 2x minus 2x plus 4, or x squared plus 4x plus 16? Sorry, choice 3 was x minus 2x plus 4. And by the way, I am not doing any editing of this video. Why am I doing that? Because I used to make videos and I used to edit them and people loved them. One time I got like 33,000 views on a video, and that made me realize that people actually really use my videos like the day before the Regents especially. And but the thing is that making the video takes 3 to 4 hours. If I want to make it perfect, I have to do my own pausing and redoing. That takes 5 hours. Then the editing process takes like 15 hours. I realized that if I just sacrifice the, uh, not deleting all the ums, the uhs, the coughs, the sneezes, whatever it is that I have to do in the middle of a video, that if I just make videos, upload them, and then let you know upload it and then literally go to another video and make another video. I could upload, hopefully, my goal is to do 7 videos every season as opposed to just one, which would be what would happen whenever I do Regents videos. So if you hear me make any mistakes, I do have the whole test completely completed and checked here. Notice all the writing. That's going to be relevant a little later. But if you hear me say or misspeak, I'm not deleting any of that. All of that is so that I can make as many videos for you, because I know you guys are really big fans of the quality of the videos that I make. So, which expression is equivalent to x plus 3 squared plus 4, x plus 3 minus 5, and choice 3 was x minus 2, x plus 4. I misspoke when I said that. So the first point from the first page that I said, from the cover page that I said I wanted to go through, is clearly indicate the necessary steps, including appropriate formulas, substitutions, diagrams, graphs, charts, etc. That is an extremely relevant point. However, as you know, it's I shouldn't even say however, because it's yes and. On the part ones, you know that your part one uh your work on part ones is not looked at all. But here is a relevant piece, and I'm going to talk about it again later on. If I literally just took my hand, and I can't do that because this is a piece of technology, but I covered the multiple choice here, that's a part two question, which is also worth 2 points. So if you don't show work on the part twos, and then you don't get your points there, but why would you not show your work on the part twos? Agreed? Well, the reason a lot of students don't show their work on the part twos, because they focus on the part ones. But if they're focusing on the part ones, but they're not showing work, how can they possibly get the question right? So the thing is, you have to show work on the part ones, just like you show work on the part twos, threes, and fours. And if you see this, all of this writing, and you don't need to be able to see it, so I know it's blurry, okay? But you see all that writing. Here's a little bit more writing, okay? You see all of that writing. That's me doing math work That's actually what a Regent should look like. And most of the time, what a Regent actually looks like is a fairly blank test, just like this one, at least on the part ones, which means that students who think they're focusing on the part ones actually are not. They're not focusing on any part of the test, not even the part ones. So if you show work on the part ones, it's it's a guarantee that you could get a better grade on the part ones, and it's a guarantee that you could actually get some of the questions or either fully or partially in the part twos, threes, and fours, and increase your grade beyond whatever grade you're looking for by easily 10% just by showing work. So how do I do this question? Now, one of the things that I'm committing to when I'm doing these problems is showing work on every single question. I want to show you how to do every single question algebraically. Okay? So because why? Because almost every single multiple choice question is looks exactly like a part two, right? So so you want to know how to do this problem algebraically. So, but I also want to teach you how to do process of elimination. After all, with process of elimination, you can take a question that you used to not be able to do and at least make it more likely that you're going to get it right, even if you don't know how to do it. So one of the strategies that I use for eliminating some choices is take a test value. Pick a test value. So here's the easy ones, and you want to know the easy ones and the difficult ones. Easy ones, x equals 0 or x equals 1. Usually those are really easy to plug in. I'm going to also include -1, x equals -1. Also an x equals like a root of a polynomial, because then a bunch of things just very quickly become 0. And then it might be easy to plug in one piece and maybe more difficult to plug in another piece. But that's the way, that's the way it goes. And more difficult, plugging in something like x equals 9 or x equals 11. Or x equals 8. Those are my three favorite numbers to plug in. Actually, I should say x equals 10, because my four favorite numbers to plug in are those more difficult ones. Of the difficult ones, those are my four favorites. And out of the easy ones, x equals 0 is easily my favorite to plug in. And actually, I'm going to do that right now, just so that you see that this actually can give us an answer, or at least eliminate some choices fairly quickly. If x equals 0, I got 0 plus 3, 3 squared, plus 4 times 0 plus 3 is 3, minus 5, which is equal to 9 plus 12 minus 5. Don't get this question wrong just by, bad arithmetic. If this is difficult for you to do, or you're not even 100% sure what the answer is, go to your calculator, plug it into your calculator. I'm not going to simulate that every single time, but I do use my calculator as a tutor. I use my calculator when I feel unsure about my arithmetic. So 9 plus 12 minus 5 is 16. The way I did it in my head is 9 minus 5 is 4, 4 plus 12 is 16. And then if I plug in x equals 0, if any of these are not 16, they're not the answer. So x equals 0, I got 5 times -1 equals -5. That one's instantly wrong. If I plug in x equals 0, I got 8 times 2, which is equal to 16. So far, this is looking okay. And this one, I plug in and I got, again, x equals 0. I got -2 times 4, which is equal to -8. That's not 16. And this one I got 0 plus 0 plus 16 is equal to 16. That one looks okay. So now I'm left with two choices. And at this point, I'd like to define what I call a passing problem. Sometimes I just write PP. What is a passing problem? So let's look at, I want to look at the conversion chart for the Algebra 2 Regents. Specifically, and for those of you who are just barely close to passing, this is extremely relevant for you. For those of you who are all know you're passing, but you're looking for an 80, or got an 80, but you're looking for a 90, or got a 90 and you're looking for a perfect grade, this is actually even relevant for you too. And it's probably even more relevant for you if you're like the 95 student trying to get 100, because you're trying to eke out every single point and you might get to a multiple choice that you just don't know how to do. And if you're actually a 95 level student, you probably can finish the test in way less than the 3 hours. This kind of strategy is extremely important for you because now you want to cement your correctness. That's the goal. For a 95 student, you want to cement your correctness. And for a student hovering around a 65, what you want to do is you want to eliminate the incorrectness, right? So now if you look at where a 65 is, a 65 out of is a 26 in your raw score only, whereas an 86 is 100. A 26 out of 86 is not very many points. It's about a third of the points in the whole test. It's actually less. It's actually less than a third of the points on the whole test, and you pass. So, but the big thing is 26 points is actually divided by 2 is 13 times 2. 13 multiple choice questions correct, and you pass, which is almost half of the, just one more than half the multiple choice questions. By the way, this one required 26 points to pass. The actual number of points to pass on a Regents can vary from 25 to 29, and I've seen 30. So from 25 to 30. So we don't want to assume that every single Regents is going to be 26. But this one did. This one was 26 points. But why do I call this a passing problem? Because if you get down to a 50-50 chance of getting it right on 24 questions, then on 24 questions, you get half of 2 points, which is 1 point, which is 24 points. Ever so slightly shy of 26 points, which means if you actually just know how to do 1 or 2 more problems, and then you get every single other question down to 50-50, you pass the test. So getting down to a 50-50 situation. So this is a situation where you're a 50-50 chance of getting it right. With a wild guess. With a wild guess. You got a 50-50 chance of getting it right with a wild guess. Now, I am not going to simulate every single question on what you can do to get the question right. But notice if you plugged in x equals 0, you're down to 2 choices. Pick any other value of x to plug in. And it's almost a guarantee that that answer will confirm to you which of these choices is correct. Like for example, I could plug in x equals 1 and I get 9 times 3. This one I get 1 plus 4 plus 16. Well, 9 times 3 is 27. And if I plug in x equals 1, I get 1 plus 4 plus 16 is 21. 21 and 27, not the same number. So if I plug that into the original and see what I get, it will confirm to me which of these answers is the correct answer. So I can do this question by just plugging in. I put a check marks next to 1 so that you could see, so that you know that once I plug that in, the problem is completely done. Okay? But that said, I promised you that I would do every single question algebraically. So there are a few ways to do this algebraically. My temptation is to introduce an auxiliary variable y as x plus 3, because then you could factor that way. Actually, that's the way I will do it. Although I did that's the way I did it on paper. The other way that you could do it is you could expand. It's actually harder to do it the other way. You could expand x plus 3 squared. You could expand 4 times x plus 3 minus 5. You get a polynomial, then you factor that. But I'm going to let u equal x plus 3. Then the original polynomial, I'm going to call this y just for notational purposes. Y is equal to u squared plus 4u minus 5, which factors, I notice that blank plus blank equals 4, and blank times blank equals negative 5, and I have to confirm that the coefficient of u squared is 1, okay? So that I could just factor immediately once I get these numbers, and I know that 5 plus negative 1 is 4, and 5 times negative 1 is negative 5. So that those numbers, I could use them to factor. I get y is equal to u plus 5 times u minus 1. Okay? And I can factor, I could plug in the x plus 3 back into the problem. That's why the reason u is called an auxiliary variable is that it's not necessary for the problem, but it simplifies the problem temporarily, but then you just replace the u right back. So you got x plus 3 plus 5 times x plus 3 minus 1, which is equal to x plus 8, x minus 2. And that confirms that choice 2 is the correct answer. Right there, not only did we get a way to do problem 1 numero uno with algebra, but we actually also learned how to do it by just picking a test value. Picking a test value is one of the most solid ways of getting by not knowing how to do the algebra. And if you appreciated that hint, please do click the subscribe button. The reason I do this is I've always wanted to have a free part of my tutoring business. My current tutoring fee actually prices out almost everybody, and that's an unfortunate thing. I know. But because of that, and my tutoring fee, and again, don't quote me on this because right now is right now, but videos are permanent. In the future, my price can change. But my fee right now is between 200 and 250 an hour. I do have tutors who tutor for a lot less than I do. Please go to JuanTutors.com to see what their prices are. But my tutoring fee is between 200 and 250 an hour, and I've always wanted to have a part of the business though that is for free, and so these videos are very much free and will always remain free. I will never have any gatekeeping like you have to be a member to see the video. This video is free. Okay. So number 2, which value to the nearest tenth is an approximate solution to the equation f of x equals g of x if f of x equals 5 over x minus 3 and g of x is equal to 2 times 1.3 to the power of x. So is it 3.2, 3.9, 4.0, or 5.6? So definitely I would think about the other thing I didn't say is that what you should do when you're watching this video, if you're watching this the day before the Regents and you're having to decide between trying the problem, picking an answer, or just watching me do it, it's actually better to pause for a second, choose an answer based on your own math, and then when you see how I do it, use my math to correct your errors, as opposed to just watching me do it. But if you do just watch me do it, that's perfectly valid too. But again, my recommendation is to pause the video, try the problem on your own, and see what you can get out of it. So I'm going to open my calculator. And this, of all problems, is literally a calculator question. No other way. I mean, other than doing it on paper, really, there's no other way to do this problem. Okay. View detached LCD. That is an enormous LCD, but I need a little bit smaller. Okay. So, and the app that I'm using right now is called Wabbit Emu. So, how do I do this question? What I do is I go, and I'm going to clear this, clear that, clear that. Let me see if, oops. Let me see if there's anything else that I need to clear. Okay. Okay. So I'm going to literally plug those expressions into the calculator. So f of x equals 5 over, and where one place where a lot of students get this wrong, the horizontal fraction bar is a grouping symbol. The diagonal fraction bar is not. So you're required to put parentheses. If you don't know whether you're required to put parentheses, think about it like this. Can you put parentheses around the denominator? Yes, of course you can. If I take away the parentheses in the diagonal fraction bar, do I have a totally different expression? Yes. Therefore, I'm required to put parentheses in the denominator for the diagonal fraction bars. Now, g of x is equal to 2 times 1.3 close to the power of x. Now, this one, I will say, do I have any process of elimination strategies that are foolproof, that don't involve just plugging into your calculator? Well, I have you can borrow my notation, but in this case, since it's literally a calculator question, it's literally just plugging in. But I do have suspicions that this one is incorrect. Why? Because exponentials blow up quickly. This one, so what that means is that they will cross almost every other function quite early in the graph. So I should say exponentials with I guess the base b greater than 1 will and then exponent greater than 0. Okay, so on those kinds of cases, they tend to blow up extremely quickly. So this one has a vertical asymptote at x equals 3. So the x coordinate, the x coordinate where these are going to cross is going to be somewhere to the right of x equals 3, according to all these answers. Now I think this one, I suspect that this one is a little bit too close to the asymptote, because the function is going to be coming from, the f of x is going to be coming from positive infinity down, um, eventually tapering off to 0. Okay, so I suspect that 3.2 is incorrect, but I also suspect that 5.6 is probably too big. And then 3.2 is probably too close to the vertical asymptote. And if you're not sure if that's a good enough argument, you could actually literally just plug it in. 5 over 3.2 minus 3, that's 5 over 0.2, is 5 times 5 is 25. And 1.3 to the 3-ish is not yet even 3, times 2 is less than 6. So I just confirmed that 1 is actually fully incorrect. Now, if you want to borrow my notation, notice that the 5.6 has an x next to it. And I do suggest in this case, I tutor students to borrow my notation, because it's very quick and efficient. I put an x next to the number if I think it's incorrect, and I put an x on the answer choice if I 100% know it's 100% definitely without controversy incorrect. One, I just confirmed verbally by plugging in 3.2 that it's incorrect. I still suspect 5.6 is incorrect. I could do what I just did, plugging in. Like, for example, 5.6 minus 3 is a little bit under 3. 5 over 3 is a little under 2. And then 2 times a number that's bigger than 1.3. 2 times a number that's bigger than 1 is greater than 2. I have a number greater than 2 and a number less than 2. They don't equal each other, and g of x has already passed the value of f of x. So I just verbally confirmed that choice 4 is also incorrect. But 3.9 and 4.0, I have nothing visually, mentally that tells me which one's incorrect. They're so close to each other. They're entirely too close to each other. So I can put them here as y1 and y2. I could do go to my table. Now notice if I can plug in whatever numbers I want, for example that. How do I change that? Above the window button, let me expand this a little bit just for now. Above my window button is the table set button in blue. So I press second and the window to the table set, second and then table set. Nope, that's not what I meant. No, I just didn't press I didn't press the second button, or maybe I double pressed it. The independent auto allows you to slide up and down using your arrow keys on x values, but it chooses the x values for you, and based on what's above the table start and the delta table, which I usually don't change at all. And then the ask is where I can put in my own numbers. And if I put in 3.9 and 4.0, now I see in my table, I'm going to make this small again because we have the big LCD. The question is when is the approximate solution? It's when are these approximately equal? When x is 3.9, one is 5.55 and change, one is 5.56 and change. There's basically the solution. And at x equals 4, we have 5 versus 5.7. These are 0.7 away, and these are a 0.01-ish away. It's actually slightly, am I right? Slightly less than 0.01 away. So the solution is very much this number, 3.9. Okay. So there we go. Uh, Again, with the subscribe button, I do appreciate it. I literally do this for free. Um, uh, the way I get essentially paid, is by your subscribing. Okay. Número tres, number three. Which equation is graphed in the diagram below? Is it, well, I see the sinusoidal graph. I see 5, 10. So when I'm looking at a graph, I read the choice. I look at the graph cursorily, and then I read the choices. I see a sinusoidal graph starting at 5, going down, and then back up, and then back down. Looks like I see the bottom and the top, also maybe 2 and 8. And I see a few cycles of it. Okay. So then the choices are -3 sine pi over 3x plus 5, negative y equals -3 cosine pi over 3x plus 5, or y equals -5 sine pi over 3x plus 3, or y equals -5 cosine pi over 3x plus 3. Now, this is what I call a 2x2 problem. So this is a nice strategy that you could use for solving this kind of problem. Do you have to draw this box that I'm about to draw? No, but I have to do it for illustrative purposes. Okay. And then there. And then, so what I notice here, they all have negatives. One of them has sine, and the other one has cos. So notice that choice 1 and 3 have sine, and choice 2 and 4 have cos. And then choice, the coefficients are -3 and then 5, and then 5, and then, or it's -5 and then 3. So choice 1 has sine and -3 and 5. So this is choice 1. Choice 2 has a cosine and -3 and 5. Choice 3 has a sine and -5 and 3. And choice 4 has a cosine and -5 and 3. So that's why I call it a 2x2 problem, because you actually need to confirm two separate independent pieces of information. And if you confirm individually the separate pieces of information, then you got the question right. But separately, if you only confirm one of the pieces of information as being 100% correct, or separately the other one being 100% incorrect, now you got a 50% chance of getting it right, which makes it a passing problem. So in this case, what do I notice? I think the easiest thing to notice is that this goes down to 2 and it goes up to 8. So the amplitude here is 8 minus 5 is equal to 3. This is the amplitude. So that is the number, positive or negative, it's the number in front of the sign. So we have a 3 in front of the numerator, in front of the sine or the cosine, that's correct. Whereas this one has a 5 in front of the sine or cosine, that one's incorrect. So 3 and 4 are incorrect, and we have a passing problem. So choice 3 and 4 are incorrect. So now the question is the answer 1 or 2. In other words, is this a sine or a cosine? So my process of elimination is exactly what I just did. I found that to be the easiest thing to see. Maybe you find something else easier to see. What I see here is that this functions, they both have a period of pi over 3 and a frequency. So the frequency is still, oh no, the frequency, I'm sorry, I misspoke. They have a frequency of pi over 3 and they have a period of 6. But they both have a period of 6 and a frequency of pi over 3. So that doesn't eliminate any answers. But I do notice that there's no horizontal shift. They have the same vertical shift, 5 and 5. The question is, this one goes down starting from the midline. That makes it a sine function with a negative in front. So that actually makes that one correct and this one incorrect. So the correct choice is answer 1. Hopefully you got something out of that conversation. And I didn't get to talk about the fact diagrams not drawn to scale. That's an important part before we do numero cuatro, number 4, because there's another relevant piece of information we're going to talk about in numero cuatro. Let's talk about this. Diagrams not necessarily drawn to scale. and this is relevant, back in the day when the SAT used to take away points if you got a question wrong, a lot of students used to say, well, that means that if you don't know the answer, you should not answer the question. That actually turns out to be 100% incorrect back then. Now, the SAT does not penalize you for getting a question wrong. It just gets you points for getting the question right. So you should actually answer every question no matter what on the SAT and ACT and APs and IBs. But why did they penalize seemingly for getting a question wrong? If you actually do the algebra, which I'm not going to do because it's no longer relevant because they changed the SAT grading. Now every question is just either 0 or 1 in the raw score. So you just answer every question. But it used to be that it actually didn't penalize you truly for getting a question wrong. It actually made it so that wild guessing was completely valueless. Wild guessing, if you haven't even read the question, because some students will get to like 25 out of 27 questions, and then for 26 and 27, they would just guess choice C or something like that. Well, well, it turns out the math works out perfectly the way they did it, so that that had zero value. But if the point is though, if you even read one iota of the question, read literally half a sentence, and then looked at the multiple choices, that's already usually enough information to eliminate something or to get an inkling of what the answer might be. And at that point, actually, it was value had value to answer the question. And if you could eliminate even one choice in that situation, well, you could get the question right, and the statistical value of that question when you eliminate answers is actually a positive number. Therefore, actually, basically, you should have on the old SAT been answering every single question. But a lot of students went into the SAT not knowing that, and they would actually lose so many points because they would not answer many questions. Same thing happens here. This is literally philosophically the same thing. This not necessarily drawn to scale messes so many students up because they see not necessarily drawn to scale and they say, oh, probably not drawn to scale. Actually, this is totally false. This is almost definitely drawn to scale. Every diagram is almost definitely drawn to scale. Now, when I tutor students, I actually tutor them so that every time in the front page when they see not necessarily, I tutor them to cross out not necessarily and write almost definitely. And let's actually cross it out this in the description of the part 1 questions. Not necessarily. I tutor my students to do this every time, almost definitely. And why do we have to address that almost definitely? Well, the almost definitely is this is the reason. Most tests have every diagram drawn to scale. A couple of tests, every once in a while, have one diagram not drawn to scale. I have seen in 2 or 3 tests like 2 diagrams and 3 tests, 2 diagrams not drawn to scale. I've never seen 3 diagrams not drawn to scale. And now when I say not drawn to scale, often it's that there's a degree of freedom that could be changed so that the reason it's not drawn to scale is that the diagram could technically be modified while keeping the problem true. Notice in this question, though, this diagram cannot be modified. This diagram is required to be unmodifiable, and it's required to be drawn to scale because they're asking us the equation of that diagram. I'm not 100% sure because I did this test about 2 weeks ago, but I think this test has 0 diagrams not drawn to scale. In fact, I think that every question has every diagram that's actually absolutely required to be drawn to scale. So you should actually assume that the diagram is drawn to scale if you get to a problem where it has a diagram and you just don't know how to do it. So if you get to a problem that has a diagram and you don't know how to do the question, try to assume it's drawn to scale and see if it gives you an answer. That's my advice. All right, number 4. Which point is in quadrant 3 and is a solution to the system below? Y equals x squared minus 24 and y equals x minus 12. Is it 4, -8, -3, -15, -4, -16, and -3, 33? Now, I said that there were 4 pieces of information in the front of the page that were relevant, and yet here's yet another one. It says here, utilize the information provided for each question to determine your answer. We did a disservice to students in elementary school as teachers and as curriculum creators when we started teaching students to cross out irrelevant information, because they actually are too young to understand that almost every just because there's irrelevant information in many problems doesn't mean that every problem is going to have irrelevant information. Yet we have curricula where, like, literally for 2 months we're training students to cross out irrelevant information, and they're always looking for the irrelevant information, when in fact almost every problem at this level, every bit of information is relevant. Now, if you had to think about what's not relevant, I mean, did Susan go to the store to buy cantaloupes or antelopes or or cucumbers or bottles of water or a soda? That's not relevant. It's the fact that she went to buy them. You know, uh, almost every piece of information in the problem is relevant. A lot of students get this question wrong. They do everything right and still get the question wrong because they ignored the fact that this says quadrant 3. So I would bet that if you happen to pause the problem and tried it on your own, there's still a 20% chance to 30% chance that you got it wrong, because both correct answers are there. Quadrant 3 looks like this: quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's the x-axis, that's the y-axis. So in quadrant 3, we have a x less than 0, and we have y less than 0. In quadrant 3, we have x less than 0, we have y less than 0. And that actually eliminates choice 1. And that's it. So now we have a 33% chance of getting right. We've raised our grade just by recognizing that we're in quadrant 3. Now, don't quote me on this, but I think that's the other answer. Yes, actually, I just did it while I was saying it. 4 squared minus 24 is negative 8, and 4 minus 12 is negative 8. So a lot of students would do everything right, get 4 negative 8, think they did it right, except that this is in 4 negative 8 has x greater than 0 and y less than 0. It's all the way down here. This is quadrant 4. It's just wrong because it's not in the right quadrant. So utilize, don't go assuming that there's irrelevant information. But not only that, it's actually a good test taking strategy. If you get to a problem and you do stuff and you do stuff and you do stuff and you realize that you're stuck, in my tutoring experience, I've found that most of the time the cause of that is that students stop they stopped using all of the information in the problem. In fact, in most of those cases, this is 80% of the time, um, you can actually fix the errors by going back into the problem and checking in the problem to see if you used all of the information. Most of the time, that's the cause. And to do that, you have to read right from the beginning, reread the problem carefully, make sure you used all the information. So now, how do I do this problem algebraically? Well, um, this is it's essentially a system of it is a system of equations. So I could actually just do a substitution. So x squared minus 24, and I have y equals x minus 12. Now notice that this x and this x are the same x. These two x's are the same x's, and these y's are the same y's. So I could actually substitute one of the y's for the other y. So that's what I'm going to do. I got x minus 12 is equal to x squared minus 24. Now I'm going to subtract x, and I'm going to go ahead and add 12 at the same time. If that confuses you, you could do those separately. But I got 0 on the left side, and that's equal to x squared minus x minus 12. And I could factor this one. This one factors as the other one did. If I look for numbers that add up to the coefficient of x, first off, I confirm that x squared has a coefficient of 1. That's relevant for this. X plus blank equals negative 1, and blank times blank equals negative 12. And I got 4 and -3. Nope. -4 and 3 and -4 and 3. That satisfies it. So I got 0 equals x minus 4, x plus 3. And then I solve each one of these individually. X minus 4 equals 0. By the 0 product property, I have a product equal to 0. Because a product equals to 0, one of the factors is guaranteed to be 0. So I solve each factor, set each factor equal to 0, and solve. Plus 4, I got x equals 4. And x plus 3 equals 0. Minus 3 minus 3. I got x equals -3. And as before, we said we're in quadrant 3. We have x is less than 0 and y is less than 0, which means that we reject this one. Not because it's not a solution, but because it's not in quadrant 3. So we're going to use this x equals -3. And now this one is incorrect because it's missing that x equals -3. But choice 3 and choice 2 and choice 4 are looking great now. We have a passing problem because we have a 50% chance of getting it right. But in fact, we're actually almost there. We just plug in the x equals -3, and we could plug it into either one, or we could plug it into both and check. I'm going to call this row 1 and row 2. Row 1, we got y is equal to -3 squared minus 24. And I want to point out here that this answer is waiting for a lot of students who choose not to put parentheses around a -3. I hope I'm proving this once and for all. Again, I'm trying to create the GOAT of all math videos. So do understand why I'm being really pedantic here. If you do -3 squared, you might want to say, oh, I mean -3, the number -3 squared. And you might say to your teacher, you know what I mean. You got to say what you mean. And -3 squared without parentheses is -9. -3 with parentheses squared, if you mean the same thing, well, it turns out that -3 with parentheses squared is 9. And the second one definitely means that the number -3 is being squared. That implies that the first one, -3 squared without parentheses, does not mean that -3 is being squared. And that answer is waiting for you as choice 4. So once and for all, if you're squaring a negative number, you're required to put the negative number in parentheses. And if that doesn't make sense to you, do understand that there was a decision made historically to make that true. A lot of teachers prove, in quotation marks, that that's true. But the truth is that there is no proof that that's true. The truth is that there has been over time many decisions that have been made in math and that we all kind of agree on. And one of them is that when you put a negative sign in front of a number and a square on top of the number, the square acts first. And there are really good reasons for that. That is not a bad decision that historically mathematicians made. But that does mean that now you have to put parentheses around the negative number before you square. And if you don't agree with that, if you said the negative sign should go first, well, that would mean that you have to put parentheses in front of the squaring every single time. And that's why this is a better decision. You got 9 minus 24, which is equal to -15. And let's just confirm with the other equation, y equals -3 minus 12. This is row 2. And y equals -3 minus 12, which is -15. Okay. And we not only did we get the answer, but we checked our answer, and we got -15. Okay, so that is choice 2. That was número 4, number 4. Now we're on número 5, number 5. And at this point, I'm going to readdress what I had talked about before. Should I show work on part 1 questions? The reason I wanted to do that in this question, notice this one says, for which equations will the value of s equals 4 make the statement an identity? For which equations will the value of s equals 4 make these statements an identity? Choice 1 or choice 2? This is a part 2 question. If it didn't have multiple choices, they might change it to say Susan said number 1, and Alex said or Susan said number one only, and then Mark said number two only. Then Billy said both number one and number two, and then which student is correct? That's a part and explain. Literally, that's a part two question right there. So, should you show work on part one questions? If you don't know how to show work on the part two question that I just made up, you don't know how to do this question. So your teacher has perhaps almost definitely been battling with you all year, saying to you, you should show work, you should show work, you should show work. And I know that a lot of students, fight that and say, no, I don't want to show work. But you need to let your teacher win that battle. You need to show work on every part one question. They're right. And if you don't show work on part one questions, you're wrong. So show work on the part one questions to maximize your grade. The proof of that, by the way, is what I just said. But the proof that a lot of students don't show work on the part one questions is this. Well, first off, in my experience, when I'm grading tests, I actually look at the part one questions and I just to look so I know what was on it. And I noticed that almost every part one test is blank. And then there's like cursory work on part twos, and then that's from students focusing on the part ones. They're not focusing on the part ones if they're not showing work, are they? They're not focusing on the part ones. They're just doing the part ones and doing nothing on the part twos, but they're not focusing on the part ones if they're not showing work. So, how do we do this question showing work? Well, we replace s equals 4 um, into the problem and see which ones are satisfied. Now, I do like the fact that if you plug in x equals 0 or x equals 1, you might actually get lucky here. Unfortunately, x equals 0 does not eliminate any of the choices, but x equals 1 would eliminate a choice. And other choices of numbers might actually help. X squared plus 4x plus 4, if I plug in x equals 2, that will eliminate. If I plug in x equals 2, remember what I said, the easy numbers to plug in are like 0, 1, and -1, but also a root. I noticed that 2, did I almost misspeak? Hold on a second. Sorry, -2. X equals -2. I almost did misspeak. -2. X equals -2 is a root of x squared plus 4, x plus 4. And so the left side equals 0. If I plug in x equals 2, I have -2 minus 2 cubed equals -2 minus 2 times 0. The right side equals 0. And you do need to know that -2 minus 2 is -4. Cubed is -64 equals 0, which is false. And that eliminates any answers that have Roman numeral 2. So that eliminates this one, and that eliminates this one. And now we have a passing problem. Now the question is Roman numeral 1 an identity? Okay? So we simplify this, and we got 4x squared minus 12x plus 9. And now the question is, what about this if we square it? So I'm going to square it using the box method. I used to not do it with the box method, but I'm finding that I like it a lot more. 2x minus 3, because there's a method called each with each, which is an expansion of FOIL. And each with each is better. But then the thing is that each with each is best organized with a box. So 2x minus 3. And I get 4x squared minus 6x minus 6x plus 9. And I got 4x squared minus 6x minus 6x is minus 12x plus 9. So that and that match. So 1 is an identity. And so it's 1 only. Notice that we verified one of them was false by just plugging in a number. We could have done it by expanding x minus 2 cubed. Nothing wrong with that, by expanding x minus 2 cubed. But another way you could have done it is by just factoring this out, x minus 2, and this one factors as x plus 2 squared. And there is a unique factorization theorem that says that any polynomial that is factored can be factored in only one way, up to maybe the ordering of the factors. That's the only other condition. And since these are two different factorizations of two different polynomials, they can't be the same polynomial. All right. After that, we go to number 6. Número 6, the number of bacteria in a sample which can be modeled by an exponential regression is shown in the table below. What I do when I'm reading a table, I just quickly read the table and I move on, then go back to the table. Time since observation began in hours: 0, 1, 2, 3, 4, 5, 4. Number of bacteria: 40, 48, 57, 75, and 82. So it's growing. Assuming this trend continues, approximately how many bacteria would be present 8 hours after the observation began? So one of the ways that a lot of students get this one wrong is by they forget that this says exponential regression. They don't bother looking to see what kind of regression it is, so they just assume that it's linear. So they said 8 hours. Now I do see that it's growing. So if I assume linear, then it goes from 40 to 82 and 8 hours. 40 plus 82, no, yeah, 82. So 82 minus 40 is 42, and then 82 plus 42 is equal to 124. So why is this relevant? Why is this relevant? Why am I doing linear? After all, we know it's not linear. I'm addressing the controversy. So what I'm talking about addressing the controversy is because there's no controversy, there's no politics here. But a lot of times when we look at what students do, you are the student, and we know that they do the wrong thing, we say, no, this is not the way to do it. The right way to do it is this other thing. But in fact, if we start instead saying that thing that you thought was true is actually false, but it's actually super useful, then we actually create learning. If you try to do it linearly, then it's false. However, exponentials grows faster than linear. Therefore, the answer is bigger than 124 by quite a bit. Okay? Which actually eliminates choice 1 and choice 2 with absolute certainty. And we have a passing problem. From going from linear and saying, no, it's not linear, but what can we say about linear? We know that the answer is going to be not those two choices. So how do you actually do this question? Well, you can make an estimate by recognizing that if it goes from 40 to 82 in 4 hours, that's approximately double. Now, this is an exponential function, so it's actually growing by a certain factor. Okay, so here's times 2. So from 0 to 4 hours. So if I add another 4 hours, I should expect to approximately times 2. And times 2, 82 times 2 is equal to 164, which is making 168 look very good. And another thing that might make 168 look good is that 80 is not double 40. It's a little bit bigger than 82, but now that's not the best. This is only an estimate. I'm liking this one, so I put a checkbox next to it. And I'm not liking this one. Notice my notation. I crossed out 1 and 2 because they're definitely false. I put an X next to 180 because I think it's false. And I put a checkbox next to 168 because I'm suspecting that it's true. But the only way to go about this problem, unfortunately, is actually doing the regression. So I recommend to you to follow the pattern that I use for regressions. Now, it's rare that regression equations appear on on a multiple choice, but they do appear. So list one, I'm going to make it the x coordinates. Now you have to be careful when you type these in. The way I recommend to be careful is to type them in first without checking. And then check in that order so that it frees your mind of the cognitive load that we get. So first plug them in without checking and then check. So 0, 1, 2, 3, 4, 5, 4. And then the second ones I'm going to plug in and then check them. 40. And should you check? Look, I know students are enemies of checking answers often. Regression problems are not problems you want to mess with. You could do everything correctly and just mistype something. And if you know how to do them, they're so quick. If you know how to do them, they're so quick. Check your answers. So 40, 48, 57, 75, and 82. Now, I'm going to quit this real quick because I realized I didn't say how to get there. I got here, there is a stat button next to the arrow keys. So the way I got here, I was on the home screen. I pressed the stat button, and the very first option is edit. So I pressed edit. Now I edited list one, and I edited list two. And look at that. I have to delete that. So I'm glad I checked this. So it's 40, 48, 57, 75, and 82. So those are typed correctly. Now how do I get the equation? Now I'm actually going to go to my catalog and turn diagnostics on. Now you might have mode in your mode button, which is next to the blue second button. You might have a diagnostics on button. So let's see. Diagnostics on, press enter, and my diagnostics are on. But if your calculator doesn't have that, which a lot of calculators don't, every function that you need is in the catalog. Catalog is in blue above the 0. So you press the blue second button and then catalog. Scroll all the way down to the D's. Scroll all the way down to diagnostics on. Press enter and press enter. Diagnostics is on. So we talked about how to get to the stat button, how to edit them. Now we go to the stat button in calc. Now we're going to do an exponential regression. That's xreg. Here it is, xreg, enter. List L1. It should say L1 already, but if it doesn't say L1, L1 is above the number 1 in blue, so we press the blue second button in L1. The Y list is the number of bacteria, that's L2. So that's above the number 2, so I press the blue second button in L2. There is no frequency list in this problem. Store regular equation. So I'm going to actually store it just so you know how to do it. I actually prefer to store it. Press the vars button, which is below the arrow keys, vars, variables button, y variables, y vars, number 1 function. And I'm going to store it as y3 because I already have something in y1 and y2. Press enter, and calculate enter. And now it gives me the exponential regression. It gives me it's 40.03, 0.003. Now I stored the exponential regression equation, which is a benefit because now I can actually use the calculator to do the calculations for me. Okay. Yeah. So, but the equation is y is approximately equal to 40.0037848. Notice I put all the numbers. Why I do that is a muscle memory fixing strategy. So I do recommend putting all the digits. I know a lot of teachers say don't put all the digits because it's a waste of time. I actually have recently started recommending that you put in all the digits for muscle memory fixing issues that I'm going to talk about in part 3, and maybe also in part 2. Times b 1.196360039 to the power of x. So now we need to replace x with 8. So y of 8 is equal to all of that to the power of 8. Okay. Now the benefit of storing the equation, the benefit of storing the equation as y3. Notice that I can actually just go to my table And if I could scroll down, I could scroll down to the number 8, or I could right now type the number 8, and it says 167.88 is my answer. Look at that. 167.88. Oops. Let me move that one. I meant to move this one. $167.88. So the answer is 167.88, which is choice 3. Okay. All right. I hope you got something out of that. If you did, I do appreciate it. Press the like button or comment that the number 6 was helpful. As you know, I do appreciate the subscribe button. Oh, and I should say actually this. I know that a lot of you are actually on YouTube, which I think is awesome. I say keep at it, learn how to do it, make sure you're doing your best to provide something that has value to somebody. My current subscriber count as of this video is 768. As of the making of 2 videos ago, it was at 760. I don't expect that many viewers in this time. So the fact that I got 8 more subscribers is actually, I really appreciate it. Those subscribers. My goal eventually is to get to 30,000 subscribers. That's my goal, 30,000 subscribers. If I get to 30,000, will I want more? I don't know. But my temporary goal is 1,000. So if you can help me get there, I really appreciate it. But on that note, we'll go to numero 7, number 7. Factored completely, x to the 4th plus 4x cubed minus 9x squared minus 36x is equivalent to x plus 9x minus 9x plus 4, or x plus 3x minus 3x plus 4, or x cubed minus 9x times x plus 4, or x times x squared minus 9 times x plus 4 times x minus 4. Now, I highly suggest thinking about which answers you could eliminate right away, because this is, for me, nearly instantly a 2x2 problem. I always recommend pausing and choosing an answer before, as you know, before I get my answer. But I did a video where I paused for a minute and I thought it was great and I think it was helpful and I was told that it was helpful by my students. But I'm not doing that for this one because you have a pause button. Immediately I see that this one and this one are not factored completely. And this one says factored completely. X cubed minus 9x has a common factor of x and x plus 3x minus 3. And x squared minus 9 has a factor x plus 3x minus 3. These are not factored completely. Therefore, they're wrong. And so what about choice 1 and choice 2? Suppose you don't know how to do this problem. Choose a value of x. How about x equals, well, if you chose x equals 0, 1 and 2 are both going to give you 0, and so is the original. So what about x equals one of the roots? How about if you choose x equals, this one has x3 and 3 and negative 3 and 4, and this one has 9 and negative 9 and I'm sorry, roots 0, negative 3, 3 and negative 4, and the first one has roots 0, negative 9, 9 and negative 4. They both have a common root of 0 and a common root of negative 4. So the question is, are the roots x negative 3 and 3, or are the roots negative 9 and 9? So how about if I choose x equals, I don't know, the easier one, 3. I think 3 is easier to plug in than 9. And I actually get, I'm not going to do this one by plugging in. I'm gonna show you the plugging in, but I'm going to show you the algebra. 3 to the 4th plus 4 times 3 squared minus 9 times 3 cubed, rather, minus 9 times 3 squared minus 36 times 3. Now I see the 3 to the 4th is 3 squared times 3 squared. So that cancels that. And I get 27 times 4. Well, 4 rather, just to keep the order the same. 4 times 27 minus 36 times 3 is 108, which is equal to 108 minus 108, which is equal to 0. So 3 is a root. And I could choose that choice, the choice that has also a root of 3. If you don't know which choice has a root of 3, then you definitely have a little bit of practicing to do. I highly recommend checking which one has a root of 3, okay? But I'm actually going to go ahead and do the factoring. And I have x to the 4th plus 4x cubed minus 9x squared minus 36x. Okay, this is equal to x times parentheses x cubed plus 4x squared minus 9x minus 36. Now, cubic functions don't have to be able to be factored by grouping so easily. They don't, but meaning that they could actually have to be split up by splitting up the two middle terms. But in this case, I could actually have the left two terms and the right two terms have a common factor, which is great. So if that ever happens, I always check to see if that happens. And if I can't do it that way, I actually graph it to find out the roots. So that's another way to do it. You could literally graph the original polynomial, find out what the roots are, find out what all the roots are. Turns out to be 3, negative 4, and 0. Okay. If I graph it and use that. But anyway, so I'm going to factor, and I notice that x cubed plus 4x has a common factor of x squared with a common factor of x plus 4. And then minus 9x minus 36 has a common factor of 9 with a common factor of x plus 4. And so then these factor as x, factor x plus 4. And then the factor pair x squared minus 9, which is why choice 4 is there waiting for students. But x squared minus 9 factors more x plus 4. X squared minus 9 is the difference of squares. X squared minus 3 squared. So I got x plus 3 times x minus 3. And that matches exactly choice 2. I hope that was helpful, that conversation, because this one is a bit of a gimme when it comes to just plugging in numbers. Plugging in. First off, choice 3 and choice 4 were not factored completely, and then choice 1 and 2 you could literally just plug in any number except 0 and 4, and it would confirm which answer is incorrect. Is that right? Any number except 0 and 4? Maybe there's some other random number that happens to be a solution to that, or a real number that happens to be a solution to that system. But point is, if you plug in 3 or negative 3, you get the answer. I think if you plugged in 1, you would also get the answer. Okay. Number 8, numero ocho, the solution set for the equation x plus 1 equals radical 4 times x plus radical 4x plus 25 is either nothing or 6 and negative 4 or negative 4 and only. So this one is one that you could literally do it by plugging in and checking. Plug in and see if the answer satisfies the equation. And in fact, very quickly, I see that by plugging in negative 4, the left side equals negative 3, and the right side is a non-negative number. I can't have a negative number be a non-negative number. A negative 3 equal what ends up being a positive number. So anything with a negative 4 is incorrect. And therefore, choice 4 and choice 3 are wrong by plugging in x equals negative 4. Again, you get a negative 4 plus 1, which is negative 3, equals radical 4 times negative 4 plus 25, which is equal to radical 9, which is equal to 3. So negative 3 equals 3, not in my book, right? So that's how I eliminated choice 3 and choice 4. So how do I get whether 6 is a solution? Literally, I could do it the same way. I just did that. I could plug in. Another way that I could do it, I just want to show you that this is an option. Okay. If I clear this and I do x plus 1, and I delete the rest of that, okay, and I plug in radical 4x plus 25. Now I'm going to ungraph number 3, 2, and 1. zoom standard to graph them. Set up the speed, calculator speed 200%, just to make it a little bit faster. I see that they do have a solution in the positive x and positive y-axis, and I could get that solution by calculating the intersect in blue. Second calc, intersect 5. The first curve, enter. The second curve, enter. And now I guess a lot of teachers recognize and students know that you could just press enter again. I do recommend guessing for reasons that involve the ability of the calculator to get a closer answer, okay? So there's what the calculator says. The answer is x equals 6. So choice 2 is going to be the answer. But I did tell you that I would do every single question algebraically. So how do I do this algebraically? I square both sides. X plus 1 equals radical 4x plus 25. I square both sides. And I get that x squared plus 2x plus 1 is equal to 4x plus 25. Now, this is an important lesson that we're going to learn here, because we're all of a sudden going to get -4 as a solution. Now, while I'm doing this and I'm going to eventually get -4 as a solution, I want you to think where I go wrong, where I go technically wrong, that I didn't go technically wrong anywhere. What is it that caused -4 to seem like a solution, yet it's not? And so keep that in mind. So minus 4x, I got that x squared minus 2x plus 1 equals 25. Subtract 25, subtract 25. I got that x squared minus 2x minus 24 equals 0. I got a 1 in front. That's good. So I could do the good old blank plus blank equals -2, and blank times blank equals -24. And I know that 4 minus 6, 4 plus -6 is -2, and 4 times -6 is -24. So that factors as x plus 4 times x minus 6 equals 0. I got a product equaling 0, so I use the 0 product property. Since the product equals 0, one of the factors equals 0. X plus 4 equals 0, minus 4 minus 4, and I got that x equals -4. There's my -4. And I got x minus 6 equals 0, plus 6, and I got that x equals 6. I want to remove you from the tendency of just eliminating the negative answer, because I have seen a problem where it's actually the positive answer that gets eliminated and the negative answer doesn't get eliminated. Yes, it's true that it's often the case that if one answer gets eliminated, by coincidence, it's usually the negative one, but that only has to do with a coincidence of the way that the problems are constructed by the test creators, not because it's often the case. So I don't want you to fall into that trap. In fact, I saw one, which it was a crazy problem in pre-calc that I didn't even cognize that this was possible, where one of the answers was eliminated, but the other answer gave 2 answers, as insane as that is. So they get more complex over time. But for now, what is it? I just got -4 and 6 as the answers. What is it that made the -4 be even plausibly false? The moment we produce, well, the moment it actually has to do, like I said right at the beginning. Actually, I said where I did something that made it plausible that one of the answers was incorrect was right at the beginning. The moment I did a squaring operation, the squaring operation, I performed an information destroying operation. I performed an information destroying operation, which is legal. You can perform an information destroying operation. It's actually totally legal. But what this implies is that extraneous solutions are solutions that might be false, might be created, and that implies I'm required. The algebra, the teacher didn't require this. The algebra requires this. The algebra requires me to check my answer. Yeah, it's actually the algebra that requires me to check my answer. So if I plug in x equals, so we check x equals -4, we've already done this. So I'm just gonna point to that. Rejected. But we do also have to check x equals 6. We get 6 plus 1. And sometimes you get something that, notice I got like -3 equals 3. But just because I like 6 plus 1 is 7 doesn't mean that 6 is going to be a valid answer. It is actually mathematically possible for the left number and the right number to look totally different. But in this case, they just don't. 4 times 6 plus 25. So I got 7 equals radical 49. And I got 7 equals actual 7. So the answer is x equals 6. Only. Super duper. Número 9. Number 9. If f of x is represented by the graph below, which translation of f of x would have imaginary roots? F of x plus 5, f of x minus 5, or f of x quantity plus 5, or f of x quantity minus 5. If I remember from my algebra, I remember that if I add or subtract a number from x, that the graph actually shifts to the left or to the right. But if I shift the graph from the left to the right, the parabola is still going to cross the x-axis at a real point, which means that if I plug in x equals 5, I still have a real root. Okay, so I can actually eliminate this one. Moving the parabola to the left or to the right doesn't create any imaginary roots. Like if I move the parabola 5 units to the, I still have these real roots. Okay, so I might not remember that this is a shift 5 to the left. Yes, 5 to the left. Adding 5 to x shifts it 5 to the left in the opposite direction than your intuition tells you. And then x equals x minus 5 shifts it, the parabola, 5 to the right. And the reason it has the opposite intuition that you might have, and the reason a lot of students still get it wrong, because if we just told you that every single time, you'd eventually catch the pattern and you'd just get them right. But the thing is that it's also the thing that is counterintuitive in the x direction is actually just plain old intuitive in the y direction. The thing that you expect to happen happens. Adding 5 to the function, this is a shift up 5. Exactly like you would expect, this is a shift up 5. So adding outside of the function shifts the function in the direction that you expect. And this is a shift down 5. Exactly the direction that you would expect, downward. Just the adding plus 5, you expect it to go to the right, but it doesn't. It goes to the left. And subtracting 5 from x, you expect it to go 5 to the left, but it doesn't. It goes 5 to the right. So do remember it. Not only that, every operation that you perform on x inside of the function has the inverse transformation effect that doing the same operation outside of the function to the entire function has. So I can multiply x by a number. It does the opposite of multiplying f of x by a number. I could divide x by a number. It has the opposite effect of dividing f of x by a number. In fact, order of operations is reversed too. I could do 2 operations to f of x, and the operations have the effect in that order. First operation, second operation. Where if I perform 2 operations on x, the operations not only do the opposite things that you would expect, but they happen in the reverse order. The second operation has the first effect, and the first operation has the second effect, and the second operation has the first effect. So that said, which one of these is going to create imaginary roots? Imaginary roots. So to create imaginary roots, if I shift this down 5, I have a graph that looks like this. It still crosses the x-axis at a real point, so it can't be this one. So it has to go up 5, and in fact, if I go up 5, I get this parabola. Notice that this parabola does not across the x-axis. Therefore, it has imaginary roots, which makes choice 3 the correct answer. And we move on to numero 10, number 10. Actually, first we move on to snacks. Before we go to numero 10, number 10. What happened with this? Which piece of information? That was this. No, that's not. Oh, that it was this. I don't. That must have. Remember, I am not undoing um any errors in the video because or no, there aren't going to be any errors in the math because I actually have done the math completely. Um, I'm not going to pause and like undo and delete any weird pauses that I have to do because of random video editing because that allows me to create more videos. I got 30,000 views on one video that I did in one season. I'd rather create 7 videos at least per season, okay? So in this case, the solution to the equation 3x squared plus 4 minus 4x plus 2 equals 2x minus 3 are, is it 2/3 plus radical 2 over 3i, or 1 plus or minus radical 6 over 3i, or 1 plus or minus radical 12 over 3, or 1 plus or minus 2 radical 6 times I? So I would highly suggest pausing the problem and thinking about how you do it. But before we actually do this question, I want to talk about snacks, and then the second thing I want to talk about is why I highlighted this. Snacks is an important piece. Again, this I'm trying to create the GOAT of all review videos, which is why I'm discussing this very important question: what snacks you want to bring to the test. I'm not sponsored by anybody, although if any of these 2 companies that I'm going to talk about want to sponsor me, great, please do. This is Fairlife protein shake. It's nice and filling, and it takes away hunger. And a great part of it, yes, it's a milk product. If you're allergic to milk, of course, you can't drink it. But if you're lactose intolerant, this is lactose free. So it doesn't do all the, gassy, let's just say it, gassy things that milk tends to do. The fact is, when even for people who are not lactose intolerant, if you're really very hungry and you drink some milk, you might find that it actually kind of bloats you up a little bit. So Fairlife being free of lactose is a good option for a quick snack that you could just chug while in the middle of a test. In fact, if you bring 2 of them, like I do, if you bring 2 of them, you could literally have one for whenever you get hungry, and then the other one when you get hungry again. All right. And then the second thing, again, another company that does not sponsor me, Pure Protein is I'm a fan of their bars. And now, again, if Pure Protein wants to sponsor me, please do. But I'm a fan of them because they're very high in protein. They're not high in they're not terribly high in carbs, although they do have the carbs that are necessary to give you a little bit of energy and a little bit of fats, but not OD so that it actually is terrible for you. It is a good option, and because they tend to be very chewy, these Pure Protein, this is chewy chocolate chip, because they're chewy, they also make you eat them slowly, so they kind of accidentally make all the digestive issues that you might have depending on what snacks you have. They kind of make them not happen. So those are the 2 main snacks that I recommend. Again, it's Fairlife milk and I like the chocolate and Pure Protein bars. Okay, so that's about snacks. So now about this question, why did I highlight this part? The formulas that you need to answer some questions in this examination booklet are found at the end of the examination. Because this is the problem that I finally get to talk about the formula sheet. Okay, so here is the test. So if scrolling makes you dizzy, please do close your eyes for a second. I'm going to scroll to the end. Okay, 1 second. Okay, so this, I'm on the formula sheet, so you can open your eyes. This is the high school math reference sheet. All of these formulas basically are relevant for the test, all right? Because you are in Algebra 2, basically every single formula that's here is relevant, including the geometry formulas, because you are, generally speaking, expected to have taken geometry before you take Algebra 2. But even then, these are really very basic formulas. Triangle area, parallelogram area, circle, general prism, cylinder, sphere, cone, pyramid. Those are really basic things. Pythagorean theorem, I don't know if I think I have probably seen it in Algebra 2 test, or at least somewhere where you could use it. The quadratic formula is extremely relevant. I'm going to take that screenshot right now, the quadratic formula, because that's kind of the point. A lot of students forgot the quadratic formula and therefore didn't get the answer to that question. But the quadratic formula is on the answer sheet. I'm personally wouldn't even have been mad if they didn't include the quadratic formula in the answer sheet. And who knows if 2 years from now they'll take it away. Well, actually, no, I know they won't, because in Algebra 1, well, actually, I don't know, because in Algebra 1, the quadratic formula does appear on the formula sheet. So it'll probably still be there, but arithmetic, geometric sequences, geometric series, radians, degrees, exponential growth and decay, and a bunch of conversion units. There are a few conversion units that you still need in real life. You know, there's 60 seconds in a minute, 60 minutes in an hour. You need to know that kilo is 1,000, milli is 1,000th, and centi is 100th. You do need to know those. But besides that, and you also know that you need to know there's a formula that's not here. Is quantity equals rate times time. Okay, but the formula sheet's here, and here I'm gonna add right away the quadratic formula, because the way to do this problem, I'm gonna bring this down now. The way to do this problem is the quadratic formula. I'm gonna move this over here, and I'm gonna really just jump into that formula. Okay, so the equation 3x squared minus 4x plus 2 equals 2x minus 3. And it is possible, believe it or not, to do this on a calculator. I'm just going to show you real quick. A lot of students think that I haven't tutored a student yet who knew this. The calculator does have I on it. If you look at the decimal point, right above the decimal point in blue, just barely visible in this camera, but it is the letter I. So you press the blue second button, press I, you have I. And if you're wondering what I squared is, just to prove that I squared is in fact -1, which is something you need to know, I squared is -1. Anyway, so you can plug I into this polynomial. That said, and get a solution. That said, I'm gonna do this algebraically. I have nothing here, to be frank, that helps me eliminate any choices at all. Yeah. So there are some things that come up later on, but I'm going to subtract 2x. I'm going to subtract 2x. Now I could add 3 afterwards, but I'm going to add 3 now because I could do that in one step. Let me bring this over here. Okay. And I got 3x squared minus 6x plus 5 equals 0. Okay. So what is it? I said that there's nothing that allows me to eliminate an answer. I happen to know that the real part of the quadratic formula is going to be negative b over 2a, and negative 6 over 2 times 3 is 1. So I know that the real part is going to be 1. Real quick, not going to have a real part with a denominator of 3. So that's why I eliminated that one. But that's the only one that I eliminated. And notice that I had to do a little bit of work before I found that out. I don't think you can get away with not doing any work here. Just do, but if you do the work, do the quadratic formula, you'll get the points. So A equals 3, B equals -6, C equals 5. Take a sip of my drink. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so x equals negative, parentheses, -6. The Regents will often give you a negative value of b just to make you have to remember to use parentheses. Literally. Plus or minus the square root of -6, yet another parentheses, squared, minus 4 times 3 times 5. Let me just make sure that I'm right there so far. Good. So all over 2a, over 2 times 3. So we got -6, nope, negative 6 is 6. plus or minus the square root. And you are allowed to go, you're on a multiple choice, you are allowed to go into your calculator. But the fun fact is you are allowed to go into your calculator even to simplify the radical. So if you actually just do that, so I got, let's see, parentheses. I'm not going to simulate this every single time but I am simulating myself as a student. -6 squared, enter. I better get positive 36, good. Minus 4 times 3 times 5. I got a negative 24 inside of the radical, okay? Plus or minus negative radical negative 24, and that's over 6, okay? Now I see that I definitely see that I have a real part of 1, so that confirms that choice 2, 3, and 4 are correct. But what about the negative radical 24? So I got 6 over 6 plus or minus, and I'm separating them because all the answers have them separated, but I don't have to separate them. I'm going to take out the negative by radical negative 1 is I. Now 24 has a perfect square factor of 4, so radical 4, radical 6 is the factor pair, all over 6. Negative radical 4 is 2. Let me just make sure. Let me change colors here so you see what I just did. Radical 4 is equal to 2. And then 6 divided by 2 is 3. And 2 divided by 2 is 1. So this is equal to 1 plus or minus I radical 6 over 3, which is choice 2. And it's a problem that I think you have the capacity to do. But a lot of students get it wrong because, you know, that battle that they have with teachers, show work, don't show work, I don't want to. But then the moment the teacher says don't show work, then suddenly students want to show work. Just like students say, the teacher might say don't use your calculator, and the student says I want to use my calculator, but then the moment the teacher says use your calculator, the students are like, nah. Let the teacher win those battles. Those are not things that the teacher's making you do because they are, oh, I don't know, um, pedantic or anything like that. They're literally telling you that because it's actually just better to maximize your score. But that said, numero 11, number 11, a culture of 1,000 bacteria triples every 10 hours, which expression models the number of bacteria in the sample after t hours. So is it 1,000 e to the 3t, or 1,000 times 3 to the t, or 1,000 times 3 to the 10t, or 1,000 times 3 to the t over 10? I would recommend plugging in t. So this t is the number of hours. I would recommend plug in like t equals 0 and t equals 10. And it does turn out, this is a very convenient fact about exponential functions. So all exponential functions can be written in terms of all other bases, with the exceptions being the like base 1, which is not one that we discuss, and of course base 0, which is the 0 function. A base 1 is just a constant function. We don't really talk about those. But other than that, every other exponential function could be written in terms of every base, which means that exponential functions can cross at exactly 1 point or all points, which means they're the same function, which means that these 4 functions, can only cross at a single point. And it does happen to turn out that if I plug in x equals 0 or t equals 0, they're all equal to 1,000. So all of them are equal to 1,000. Unfortunately, it doesn't tell me anything. In this problem, it happens to tell me nothing, which means that if I plug in t equals 10, it is 100% guaranteed to give me the answer. This will give me the answer. So if I triples every 10 hours, that means that the population of 10 at 10 is equal to, well, 3 times 1,000, which is equal to 3,000. So I'm going to use my random number generator to choose which number to simulate that I'm going to plug into for the whole test. For the whole test, I'm going to plug into, if choice 2 is available, I'm going to plug into choice 2 just to show you. So if I plug into choice 2, again, t hours, 10 hours, 1,000 times 3 to the power of 10 turns out to be way bigger than 3,000. 1,000 times 3 to the power of 10. Not 3,000, in the 5 millions, right? In the 5 millions? In the 50 millions. Okay? So plugging in the answer, plugging in into each answer choice will give you the answer. Will 100% give you the answer. So now the question is, how can I do this algebraically? Well, if it triples every 3 hours, the equation, let P equal the population, and then T equals time in hours, and then T sub triple is equal to a number, is equal to the time it takes to triple the population. Then the equation P is equal to 1, and also P0 is equal to the initial population. So P is equal to P0 times 3 to the power of T divided by, T is divided by T triple. So there we go. So P is equal to 1,000 times 3 to the power of T over 10. And there it is. We eliminated choice 2 by plugging in, but we could have eliminated choice 1 and 3 also by plugging in. We actually just confirmed that choice 4 is the correct answer. All right. From there, we hop over to numero dos, number 12. An initial investment of $5,000 in an account earns 3.5% annual interest. Not bad for a basic savings account. Which function correctly represents a recursive model of the investment after n years? A equals 5,000 times 0.035 to the n, or A0 is 5,000 and AN equals AN minus 1 times 0.035, or A equals 5,000 times 1.035 to the n, or A0 equals 5,000 and AN equals AN minus 1 times 1.035. Now, a lot of students will get this one wrong by not even bothering to plug in. If you bother to plug in, you actually immediately, so this is actually technically a 2x2 problem. Why? Because two of the answers agree in number, and then 2 other answers agree in number, and then 2 of the answers agree in format, and then the other 2 of the answers agree in format. So this is the 2x2 problem that we got. Okay. So how is it? There's 2 answers that are recursive, and there's 2 answers that are closed form. So closed recursive or closed form or explicit. I'm going to say explicit. And then we have the answers that are they agree, or the value A of 1 is correct by plugging in, and A of 1 is incorrect. And now the only thing is, actually I should say A of 1 is correct versus incorrect. I guess I can't say it that way because we have to think about what it is. So it's A of 1 equals 5,000 times 0.035, 175, or A of 1 equals 5,170. And so you actually have to go through and see which ones this is. Now, the recursive ones are choice 2 and 4. And the explicit ones are choice 1 and 3. So if you plug in A of 1, they all agree at A of 0. So A of 1 actually for choice 1 is 175. and it's explicit. So this is actually choice one. A of uh, and choice two, this one is recursive, and A1 is equal to 175. Sorry, choice two. Choice three is explicit, meaning that you could just plug in, let's say, for example, n equals 100, and you just immediately know n equals 100. And choice three equals 5,175. Oops, it's choice three. And choice four is recursive, and A of 1 equals 5,175. So immediately we could eliminate the explicit ones because it did insist on recursive. Do you have to create this table that I just created to eliminate choice 1 and 3? No, you just have to actually know which ones are recursive and which ones aren't. This is recursive. This is recursive. So those could be it, right? I'm gonna put a checkbox next to those. And this is explicit. You don't need to know the previous answer to get the current answer. And this one's explicit. In other words, you don't need to know like A of 19 to get A of 20. So this one is not the answer. So it's either choice 2 or choice 4. Now, is there something in the formula sheet that might help us? And it happens to be that there is. I'm going to take a picture of both of these because arithmetic and geometric sequences, they're known by another name. Okay? They're known by another name. Arithmetic sequences are also called linear. So these are linear functions. And geometric sequences are also known as exponential functions. And when you invest and you're gaining a certain amount of interest every year, these are exponential, which means that they have to take on this form. Now, unfortunately, though, this is not a recursive one. Uh, this is explicit, which allows you to perhaps eliminate some answers. So, but it does allow you to at least get A1. So how is it explicit? They have to get, so recursive has to give you a starting value. Now, this one starts, for the geometric sequence, that one starts at A of 1, whereas choice 2 and choice 4 start at A of 0. But let's not confuse that for a second. So it has to give a starting value. In this case, they gave us that A of 0 is equal to 5,000, or equivalently, A sub 0 is equal to 5,000. Okay? And then the second thing that it has to give us, it gives the current term in terms of the previous term. Okay? So, in other words, it doesn't give you a formula that gives you A sub 1,000 or A of 1,000 in one step. To get A of 1,000, you actually need A of 999. To get A of 53, you actually need A of 52 in the recursive form. So A sub n is equal to A sub n minus 1, in this case, times some number r. And actually, the geometric sequence method or the recursive or the closed form method actually gives you the correct answer. Notice that to get the balance at year one, you know you're making an investment that's growing. So you have to have more money than you started with. So A of 1 has to be the 5,000, which is A of 0, times the original amount plus the interest rate, 0.035. And this one is, that one gives you exactly that. This one does not. Does not. but also, again, recursive, A2 is equal to A1 times 1 plus 0.035. A3 equals A2 times 1.035. A4 equals A3 times 1.035. And in general, AN equals AN minus 1 times 1.035. And so that gives us the format of choice 4. And therefore, choice 4 is the correct answer. Choice 2 would imply that the investment is shrinking by tremendous amounts every year. And choice 4 implies that it's growing ever so slowly, as many investments do. Okay. So, número 13, number 13, which expression is equivalent to 2xy squared times the cubed root of x squared y? Is it 2x to the 5/3 times y to the 7/3? Or is it 2xy? Or is it 2x to the 2/3 times 2y to the 2/3? Or is it 2x to the 7th y to the 4th? So please do think about which ones you would eliminate. I'm going to go ahead and eliminate two of these right away. There's nothing that is going to eliminate positive powers of y. This has a positive power of y of 1, so this cannot be the answer. Also, we have a root of x squared. So we have a fractional power of x squared. We do not have x squared cubed. So we don't have, there's no way we're going to get x to the 7th power. X to the 1 times a fractional power of x is not going to be equal to x to the 7th. A small fractional power of x is not going to be equal to x to the 7th. So I already eliminate those. So the answer is either 2x to the 5/3, y to the 7/3, or 2x to the 2/3 and y to the 2/3. In fact, I'm strongly suspecting why that one's not the answer already. In fact, I already know that if you know why that one's not the answer, please do mention it in the comments. But there is a reason why I can immediately know why that one's not the answer. Okay. But I want you to think about that. What I just said about choice 2. Choice 3 is eliminable for the same exact reason. But I told you that I would want to do these algebraically. So 2x to the 1, y to the 2 cubed root of x squared y is equal to 2x to the 1, y to the 2 times x squared y to the power of 1/3. So that's worthwhile knowing that a number, the cubed root of a number is equal to that number to the 1/3 power. So that is, that simplifies really nicely. And then it's also worth knowing, so 2x to the 1, y to the 2, that the exponents distribute over multiplication. Exponents distribute over multiplication. The exponents also distribute over division. Exponents do not distribute over addition or subtraction. So do remember, exponents do distribute over multiplication and division. They don't distribute over addition and subtraction. Let's write that down. So that, for example, AB to the M is equal to A to the M times B to the M. And also A over B to the M is equal to A to the M over B to the M. And exponents do not. So this is teaching the controversy. This is the thing that a lot of students think is true. So exponents do not distribute over addition and subtraction. So for example, a classic place where students get messed up is a plus b to the power of 2 is actually equal to a squared plus 2ab plus b squared, not equal to a squared plus b squared. Not equal to a squared plus b squared. A minus b squared is equal to a squared minus 2ab plus b squared, which very clearly is not equal to a squared minus b squared. In fact, a squared plus b squared have different factorizations. A squared plus b squared factors over the complex numbers, and a squared minus b squared factors as a difference of two squares. A plus b, a minus b. Okay? Again, this one is equal to a plus b, a minus b. Let's write that a little bit neater. I know that it's tiny. A minus B. Okay, so this one, I'm going to distribute the exponent. I get x to the power of 2 times 1/3 times y to the power of, well, 1/3. And so then this is equal to, well, 2x to the 1. I'm going to now use the commutative property to move this power of x next to the other power of x. X to the 2/3, and then y to the second times y to the 1/3. And now the second rule to know is that b to the m times b to the n is actually equal to b to the m plus n. Okay, so now I can actually add these exponents. 2x to the 1 plus 2/3 times y to the 2 plus 1/3. And I could use my calculator to add these fractions. Well, I remember I didn't know this as a child, nor as a college student. I learned this as an adult from a teacher, that you could convert numbers to fractions. I'm going to add the 1 plus 2/3 and convert it to a fraction. 1 plus 2/3. If you press the math button under the alpha button, the very first option is arrow frac, which means convert to fraction. 1 plus 2/3 is 5/3. 2x to the 5/3 times y to the power of 2 plus 1/3, 2 plus 1/3, math, arrow frac, convert to fraction, 7/3, which matches that and that. So the answer is choice 1. Isn't that super duper? So that problem easily could be a part 2. And in fact, I've seen that as a part 2 in other tests. Not with the exact same numbers, of course, but I've seen that basically as a part 2. Okay? Número 14, number 14. Which statement must be true about the polynomial function k of x equals negative 2x cubed minus 11x squared minus 12x plus 9? Is it that x minus 3 is a factor of k of x? Or is it that k of 0 is equal to 9? Or is it that k squared over x plus 2 has a remainder of 5? So I invite you to see which of these answers are more obviously true, which allows you to eliminate some choices. Okay. Now, I hate the fact that all of the choices have 2. So it actually ends up being a waste of time to check that choice that Roman numeral 2 is true. I don't like that they had that. But Roman numeral 2 was included in all the choices. Therefore, therefore, under the assumption that it's a well-written problem, choice Roman numeral 2 is correct. So the only other possibilities is whether Roman numeral 1 or Roman numeral 3 is or is not true or false. Okay? And it's that x minus 3 is a factor of k of x, or k of x over x plus 2 has a remainder of 5. The way I'm going to do these, I'm going to actually do both of these with synthetic division. So the coefficients of k of x are -2, -11, -12, and 9. And the factor, I'm going to divide by x minus 3. That's equivalent to checking if 3 is a root of k of x. And I bring down the -2. Multiply by 3, I get -6. -6 minus -11 minus 6 is -17. -17 times 3 is negative 51. -51 plus -12 is -63. Now, I'm pausing for a second because I actually, when I was doing this work, I don't know, I must have dropped my coffee or right at that moment, or the effects of my coffee right at that moment, because I made maybe like 7 different mistakes on this problem. So I'm doing this, I'm realizing I'm doing this a little bit live. I thought I did this part correct, and even this part wasn't correct. So negative 63 times 3 is negative 189. Add negative 189 and 9, and I get negative 180. The remainder is not equal to 0. Therefore, negative 3, no, 3 is not a root. 3 is not a root. And x minus 3 is not a factor of k of x. Okay, so Roman numeral 1 is not the answer. So any answer that has Roman numeral 1 can't be it. I've confirmed that that one is not the answer. And I've confirmed that this one is not the answer. Now, could I have done that in another way? Yes, I could have evaluated the original polynomial at x equals 3 using my calculator. I could have literally plugged it into y equals and then gone to the table and plugged it in there. Or I could have gone here, negative 2 parentheses 3 to the fourth, etc., and plugged in the rest of it. Either one of those would have confirmed that that 3 is just not a root of the original polynomial. I could have also confirmed it by recognizing if I plugged in 3, I'd get a very negative number, another very negative number, plus a tiny positive number, 9. Not k of 3 is not equal to 0. Is not equal to 0, not even close. So that's another way I could have done it without fully plugging in. So let's check Roman numeral 3. If k of x over x plus 3 has a remainder of 5, I'm going to do that same division. I'm going to do this one by synthetic division again. Negative 2, negative 11, negative 12, and 9. Plug in, now I have to put the root in, negative 2. And this goes down, negative 2. Multiply negative 2 times negative 2, I get 4. 4 plus negative 11 is negative 7. Negative 7 times negative 2 is positive 14. Negative 2 times negative 12 plus 14 is 2. Negative 2 times 2 is negative 4. 9 plus negative 4 is 5. So the remainder is equal to 5, which is correct, which means that Roman numeral 3 is true. Roman numeral 2 we've already confirmed is true because it's literally in every choice. Therefore, choice 3 is the answer. Another way you could have done it again is by plugging in x equals negative 2 into the polynomial and seeing what you got. In other words, dividing by x plus 2 and seeing what the remainder is equivalent to plugging in x equals negative 2 and seeing what the value is. That's actually the remainder theorem for polynomials. Okay, número 15. Number 15, to prepare for lacrosse tryouts, Cole is increasing the amount of time he spends at the gym. This week, he is spending 150 minutes there, and he plans to increase this amount of time by 2% each week. That's not a bad increase, and it's not a bad amount of time for a single week. Anyway, I said that just to give myself some intuition on the problem. The amount of time in minutes that he plans to spend at the gym t weeks from now is given by the function a of t equals 150 times 1.02 to the t. So they gave us the function, which is super duper for them. In terms of the daily growth rate now, the amount of time Cole is planning to spend at the gym can best be modeled by the function, which one? A of t is equal to 150 times 1.14869 to the t over 7, or 150 times 1.14869 times to the 7t, or 150 times 1.00283 to the t over 7, or 150 times 1.00283 times to the power of 7t. Now, remember that t is the definition of a variable can't change in a problem. So this one requires us to notice that t is the number of weeks, t weeks. If you hear like little mini pops or explosions, I'm recording somewhat close to the 4th of July. It's actually 2 weeks out. So there's someone shooting fireworks outside. So anyway, so T is the number of weeks. It can't be anything except the number of weeks. It doesn't just like change definitions mid problem. That's not legal. And now A of T is also, again, the amount of time in minutes that he plans to spend at the gym. So in this answer and in the answer choice, which means that the answers actually have to match in value. The answers actually have to match in value. So one of the ways, and I said that I would always demonstrate by plugging in one of the choices. You could do this problem by plugging in. One of the ways that you could do this is by going to Y and or you can go into the home screen and just plug in a larger number, large-ish number. But I'm gonna plug in, take this off, take this off, okay? And I'm gonna get 150, so A of T is 150 times 1.02 to the power of T. In this case, on the calculator, X. And then I'm going to plug in choice 2 for every single one to demonstrate my plugging in. 150 times 1.14869 to the power of 17. Now, this one is not looking great because this is a bigger base to a bigger exponent. This one should blow up a lot faster. It shouldn't be the same as the original function, based on my intuition. So if I press Y equals and I go to the table, well, the table doesn't quite do it for me. So I'm going to actually change back the table set. Remember, table set is in blue, so I press the blue second button and then table set. I'm going to change the independent from ask back to auto so I could just do scrolling. And I'm going to scroll, and I see very quickly that these numbers don't match at all. Got 190, 197, for example, here, and 920. They don't even come close to matching. So choice 2 is not the answer. Okay? Choice 2 is not the answer. Okay? So the tough thing, one of the tough things for this question is that if you do what I just said, well, and you plug in on the calculator, you're going to find that two answers seem to match the original function. And so you actually have to know a little bit about what it's saying in terms of the growth rate. But I will say this, just like I said with this one, the large base and a larger exponent. So I should say larger base, larger exponent. That means it blows up faster. So that choice 2 can be the answer. But without plugging in choice 3, this is a smaller base and a smaller exponent, which implies that it grows slower. So that means choice 3 can't be the answer either. That's just by mathematical intuition. So now I have a passing problem. It's either choice 1 or choice 4. Now, if you plug into choice 1 and you take some test values, it turns out to match the original function. If you plug into choice 4 and you take some test values, it turns out to match the original function. So it's like, well, how could it be that two answers match? It can't be. There's a legal thing. These are multiple choice questions. It can't be that two answers match and therefore two answers are correct, because it's a multiple choice. Only one answer can be the one. There can be only one, like they said in The Highlander, for those teachers who remember that show. Great show, by the way. This is the thing. It says in terms of the daily growth rate. In terms of the daily growth rate, that's the piece that you need to know. You need to know how the daily growth rate works. The daily growth rate. Well, 2% per week. That's a weekly growth. That's a growth. R is equal to 1 point. So this A of T is equal to A of 0 times 1 plus R. Let's write that again. 1 plus R to the power of t, where r is equal to the weekly growth rate, right? That's the way the formula works. So what about 2% per week? That means r is equal to 0.02. That implies that the daily growth rate comes from. So you need to know that's there is something that is not on the formula sheet. There's 7 days is equal to 1 week. You do need to know that. Okay. There you go. You do need to know that 7 days is equal to 1 week. So the daily growth rate comes from the 1.02, 1 plus 0.02 to the power of 1 over 7, which is equal to this number, approximately. You could have done 0.02 divided by 7, and you would have found that you would have gotten basically the same number, but that's not always the case. So we do want to know it this way. If you did 0.02 over 7, you would have gotten a very, very similar number. But this comes from this 1.02 to the power of 1 over 7. If you go to the calculator, 1.02 to the power of 1 over 7, 1.00283. So there's our numbers. Okay. There's our numbers, 1.00283. And then the next number is a 2, and there we go. And then the exponent, so that's 1, is equal to the number of days now. But then if there's 7 days in 1 week, which is equal, then that's equal to the number of weeks times 7. It's equal to 17. And there's a 17. So it is choice 4. So where did choice 1 come from? Choice 1 came from doing exactly the opposite of what we just did. Taking 1.02 to the power of 7, and then taking the t and dividing it by 7. But what does that mean? What does the 1.02 to the 7th represent? Well, that's the growth rate per 7 weeks, which there's no special amount of time that's 7 weeks. And then what does t over 7 represent? Well, it's 1/7 of a week, which is a day. 1/7 of a week, which is a day. But then again, the thing is that the exponent has to equal the number of days. In 1 week, there aren't 1 day. So in 7 weeks, there isn't 1 day. In 7 weeks, there isn't a single day. It's the opposite way around. In 7 days, it's 1 week. The best way to understand it, I think, is what we just said. That you do need to know that the daily growth rate comes from the weekly growth rate to the power of 1 over 7. The same way a yearly growth rate can be converted to a daily growth rate by taking the 1 plus the yearly growth rate and taking that to the power of 1 over 365. That said, number 16, Mr. Zachary posts review assignments on the Beta Math website. That must be a shout out to Delta Math. Shout outs to Zach. Zach's a good guy. Zach is the guy who founded Delta Math. So, well, I didn't even notice that it said Mr. Zachary. Mr. Zachary posts review assignments on the Beta Math website for his students. On his last test, 49% of his students used Beta Math and passed. Overall, 68% of his students used Beta Math. Approximately what percentage of Mr. Zachary's students passed, given that they used Beta Math? 19%, 32%, 33%, or 72%? We do need to know what this means. Passed, given that they used beta math. Given that. So what does given that mean? It means that we're taking the probability with the whole group being only students who use beta math. Okay. So that means, so the number, or the percent that passed, so hold on, the percent that used beta math is equal to 68%. Okay. Now the percent that used beta math in past is equal to 49%. Now notice that we are taking a whole only from students who use beta math, which means since we're reducing the size of the whole group, the number that passed, the fraction that passed is greater, which means that the answer, so this is for process of elimination, this and this imply the answer is greater than 49%. So now our process of elimination eliminated choice 1 and choice 2 and choice 3. And without knowing how to do the problem, we have a guarantee that we're going to get the answer correct. You see, process of elimination and these kinds of strategies, getting to an answer and actually showing the work and using correct math to eliminate incorrect answers often, can get us to the point where we get the question completely correct. In fact, there's a lot of problems where I simulated and told you what you would do to get the problem correctly. Literally plug in one number, eliminate some answers. Plug in a different number, eliminate more answers until you get the answer completely correct. That happens to a lot of problems. You could literally get the answers by just plugging in. This one, we just did some correct math and realized that the answer had to be greater than 49%, which left us only one answer. But how do we do this? So the approximately what percentage of students pass given that they use beta math, the answer is going to be equal to the percent that passed and used beta math divided by the percent that used beta math, which is equal to 49%. Ooh, that 9 turned into an arrow percent, divided by 68%. And this is the first time you probably divided percents to get a percent. But it is a fraction. But of course, all fractions are equal to percents. 49 divided by 68. And then we multiply by 100. Put that there for a second, okay? Equals, so we have to say times 100. Now I'm gonna talk about what I recommend to students on the part 1s so that we could actually fix the muscle memory for part 2s, 3s, and 4s. I do recommend to students to write the entire decimal that they found, 72.058822353 percent. Now, if you say that takes up too much time, your teacher probably told you that it takes too much time and then you like to do it anyway. And then now I'm telling you to do it anyway. So you might be saying, nah, I don't want to do it now. But this is a muscle memory fixture. The muscle memory fixture is that some teachers are like, always round to this number or always not round to that number. And then the test says, actually round to the number that I said as the test maker. And then we get to that point, and then the test says round to the nearest hundredth, but students always insist on rounding to the nearest hundredth, thousandth, or something like that, and they get it wrong. Or round to the near, they always round to the nearest tenth, and so they get it wrong. Always round to what the test says. The muscle memory fixture is by writing the whole number, which only took 6 seconds. Remember, the test is 3 hours long, which is about 10,800 seconds. You only took 6 seconds out of the 10,000-ish minutes or seconds. Didn't take an appreciable amount of time. And now this rounds, all of these are rounded to integer percent, so 72%. Confirming that the answer is choice 4. Shout outs to Zach. I didn't even realize that they put your first name on it. I knew that they were giving you a shout out, that they were giving you a shout out by calling it a data math, and then I didn't even realize that they said Mr. Zachary. So shout outs to Zach, the creator of Delta Math. Número 17, number 17. Given sine theta equals 7 over 25 and theta terminates in quadrant 2, what is the value of tan theta? Is it negative 7 over 24, negative 24 over 7, 7 over 24, or 24 over 7? So how do we go about this problem? If theta terminates in quadrant 2, again, this is all information that we need. There are ways to go about it without using a calculator, or with using a calculator. You can get the angle approximation. You can get the angle between 0 and 90 by, in other words, you can get the reference angle with a calculator. Go to second sine to get the sine inverse of the fraction 7 over 25. Now it's going to give you a fractional number of degrees. Let's make sure our mode here is in degrees, just because I haven't used in degrees. You do on the Algebra 2 need to be able to fluidly switch from degrees to radians. So I'm currently in degrees. I get a funny decimal number of degrees, which is normal. But if I get the, because this is not a nice triangle, but if I get the tangent of this answer, then I get a fraction. And if I convert that to a fraction, I get 7 over 24. So the answer has to be either plus or minus 7 over 24. That eliminates choice 2 and choice 4, because that's 24 over 7 and negative 24 over 7. The only piece that I haven't used yet is quadrant 2. It has to be in quadrant 2, and then that's where I use ASTC. ASTC in quadrant 2, here sine is greater than 0. And tan theta is therefore less than 0. Therefore, the negative sign. And this is, by the way, a 2x2 problem. I choose that one. But I told you that I would show you how to do every single problem on paper, because any given problem can ask you to show work. So sine of theta equals 7 over 25. Let's see. There we go. Now 7 over 25 in quadrant 2 put a right angle there, 7 and 25. Now I could do this. So this is, in other words, this is theta, and this is theta ref. Now sine theta is 7 over 25. Sine theta is equal to the opposite leg over the hypotenuse, which is equal to 7 over 25, which is why the opposite leg was 7 and the hypotenuse was 25. That's why I wrote those. Now, if I wrote the x coordinate as x, I could use the Pythagorean theorem, and I can, which is in the formula sheet, and so that even though this is geometry, this is not geometry, rather, this is Algebra 2, you're expected to know the Pythagorean theorem. So this is true for right angles. So this is where C is the length of the hypotenuse, and then A and B are the lengths of the legs. So I got the legs x squared plus the legs 7 squared equals 25 squared. And or you could recognize this as a Pythagorean triple. But suppose I didn't, I could solve for x. X squared plus 49 equals 625. Subtract 49, subtract 49. I got that x squared is equal to 576. I take the square root of both sides, and I get the plus or minus in there. And I got that x is equal to plus or minus 24. Now, a lot of students are used to rejecting one or the other, or not putting the plus or minus. Every time you put a square root to solve a question, you always got to put the plus or minus. But in this case, I'm going to actually reject the positive answer. The positive answer. See, I love that we're rejecting the positive answer so that we learn that we're not always rejecting the negative answer. In this case, we're rejecting the positive answer because in quadrant 2, x is less than 0. So x is negative 24. And now tan theta, how do we get this? This is the opposite leg over the adjacent leg. And this is equal to the opposite leg is 7 over the adjacent leg is negative 24. It's equal to negative 7 over 24. So it is choice 1, numero uno, choice 1. I like that question. And on that note, numero 18, number 18, a family-owned grocery store in New Hartford, New York, employs 49 people, good for them, whose ages are approximately normally distributed with a mean of 36 years and a standard deviation of 6.2 years. Okay, so here's the mean, here's the standard deviation, or sigma, okay? Ryan has been, and this is the number of people, Ryan has been hired to work at the store. He is 30 years old. How many people who work at the store would you expect to be younger than Ryan? Now, how can I eliminate some answers? There's 49 people. I know that this is approximately normally distributed, so there's a bell curve going on here. I should actually do it this way without a... So normally distributed with a mean of 36 and a standard deviation of 6.2. So this is going to be 29.8, and this is going to be 42.2. So here is 68% of the data. So this is the 68% of the data. The 68, 95, 99.7 rule. Again, this is the GOAT of review videos. This is something you need to know. 99.7 rule. This says that 68% of the data is within one standard deviation of the mean, standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean, and 99.7% of the data is within 3 standard deviations of the mean. Okay. So, if 68% of the data is within 1 standard deviation of the mean, then that means that, well, 100 minus 68 is equal to 32. 32 divided by 2 is equal to 16. So that means that 16% of the data is to the left of 29.8-ish, and another 16% of data is to the right of that. Since he's 30 years old, which is almost exactly 29%, 29.8%, our best estimate is 16% of all people. So 0.16 times 49, that's this 16%. When I say 16%, I mean this 16%. Let's make sure that, to be clear, that's a 16%. 16%. So let's put that in the calculator. 0.16 times 49 is 7.84, which is just slightly less than 8. So which answer should it be, 7 or 8? This answer is closer to 8, so this is looking good. But we should have rejected 41 from moment 1 because it's way more than half of the people. Way more than half of the people. But 7 or 8, they're so close to each other, it's really hard to decide why it would be one or the other. Okay, so there is another way that actually is a more official way of doing it, and we do need to know how to do the problem. And this can appear on a part 2 question. Okay, so or part 2 or part 3 or part 4. So there's the distribution button above the vars button in blue. So you press the blue second button. Um, Excuse me. And then you go to normal CDF. Okay, normal CDF. Didn't I just press normal CDF? Sorry. Clear that. Hold on a second, quit. So okay, so there is a second way of doing this problem. I just ran into a bug in the calculator, which is interesting. So I want to make sure I tell you what happened. It's the second one, normal CDF. So if you want to get a more exact answer, again, this can be a part 2, and you literally have to write down how you did it on the test, as insane as that is. It's the second option, normal CDF. The bug that I ran into is that I accidentally clicked on the wrong one before. And then when I kept going back and clicking back on normal CDF, it kept putting in normal PDF, but putting in weird things into normal CDF. So how do I know that I'm in the right one? Normal CDF has a lower limit and an upper limit. I want everything to the left of the data, including all the way down to negative infinity. So you're literally including people um, that have a negative age, as weird as that is. But this is just how how bell curves work. They don't just end randomly; they keep going forever. At least the model works that way. So then the lower limit right now, we want it to go to negative infinity, but the calculator can't handle negative infinity. So they put 1 e to the 99, which is literally negative 1 e to the 99, which is negative 1 times 10 to the 99th power. Okay, the upper limit is going to be going up to the age that he is 30. Okay, and then the mean, that letter mu is mean, which is 36 in this case, the mean. The standard deviation, they told us, is 6.2. So you do need to know how to do this. And because, again, it does appear in a part 2. Press enter. And notice what it actually wrote for us. I'm going to actually bring the screen for us and then press enter. Actually, I'm going to bring the screen down. Actually, I'm going to, because funny things about the way this software works. Okay, so on a part 2, how would you do this on a part 2? After all, there's no algebra that we did. You would literally write exactly this: normal CDF parentheses -1 E99, which is -1 times 10 to the 99th, which is -1 followed by 99 zeros, comma 30, comma, which is the age, and then 36 for the mean, and then 6.2 for the standard deviation. And this is equal to not 16% of the data, because it's 30 is actually here. It's actually 0.1665866,273. And then so now the number of people is equal to this number times the total number of people, 49, times 49. And now we get a number that's closer to the actual answer. See that? 8.16, which is approximately 8 people. Yes, you do. Yes, you do have to know how to do that. As insane as that is, it shocked me to find out that that was a thing that was being tested on, because they didn't really test it that way when I was in school. In fact, they didn't even test that at all when I was in school. So it's something that I learned as an adult, as a teacher, for the purposes of teaching. That said, number 19, number 19, the function d of x equals cubed root of x plus 2. For the function d of x equals cubed root of x plus 2, the inverse function d inverse of x is equal to the cubed root of x plus 2, or x cubed plus 2, or negative cubed root of x plus 2, or x cubed minus 2. This says d inverse. So a lot of students are like, oh, this must mean the 1 over that. Luckily, 1 over that is not that, but the inverse function. This is the inverse function. This is literally the process that we go through by switching the x and the y. So I know the inverse of a cubic. I'm sorry, the inverse of a cube root is going to be a cubic. So this is a cube root. So the inverse function is going to be a cubic. So immediately I could eliminate choice 3 and choice 1. Choice 1 is just f of x. Now, do functions exist where the inverse function is the same as the original function? Yeah. They're not that common, but it's definitely not true for powers. It doesn't happen with powers. Or fractional powers. So it's either way, it's not choice 1 and choice 3. It's going to have to be a cubic. So choice 2 and choice 4. So even if you didn't know how to do it, we have a passing problem. We have a passing problem because we have a 50-50 chance of getting it correct, even if we don't know how to do it. So how can we actually do it? By plugging in numbers. So if we're talking about process of elimination, how about plugging in x equals 0? Well, d of actually, I'm going to plug in a different number. I plugged in x equals 0 as a test number in my paper, but plugging in x equals 0 will work. But I'm going to plug in an easier number, and x equals 6. How could you say that x equals 6 is an easier number to plug in? Well, I know that if I plug in x equals 6, I get a nice cubed root. D of 6 equals the cubed root of 6 plus 2, which is equal to the cubed root of 8, which is equal to just plain 2. Which means that d inverse of 2 has to be equal to 8. And then if I plug in 2, I got 2 cubed plus 2. Oh, not 8, 6. Ooh, I misspoke. D of 6 is 2. Therefore, d inverse of 2 is 6. Got it? So d maps 6 to the number 2. And then, therefore, d inverse maps 2 to the number 6. So I did misspeak, but I corrected it. And if I plug in 2, I get 2 cubed plus 2 is equal to 10. Doesn't look good. And 2 cubed minus 2 is 8 minus 2, which is equal to 6. That's looking good. How do I actually do it? After all, this could be a part 2 question. So the way I do it, I write y equals, I write y equals the cubed root of x plus 2. 2, I switch the x and y. So I get that x equals the cubed root of y plus 2. And then step 3 is solve for y. Okay? So I get here, how do I solve for y? I got to get rid of the cubed root, so I could cube on both sides. I get x cubed equals y plus 2. Subtract 2, subtract 2. I get that y is equal to x cubed minus 2, which is choice 4. And that's how to do it for a part 2 question. Do you see how every single part 1 really could be a part 2 question if they literally just reworded it ever so slightly? That's not a coincidence. That's just the way they write the problems. Okay? So, numero 20, number 20, given f of x equals x to the fourth plus x cubed minus 3x squared plus 9x minus 108, and f of 3 is 0, which value of f satisfies f of x equals 0? Well, -4 and 3 only, or -3 and 4 only, or plus or minus 3i and -4 and 3, or plus or minus 3i and -3 and 4. Yeah, I mean, I would say plug in some numbers and find out. They told us that f of 3 is 0, right? They told us that f of 3 is 0. So, which values satisfy f of x equals 0? I mean, any answer that doesn't have x equals 3. X, right? X equals 3, not there. X equals 3, not there. As insane as that is, they literally just told us 2 of the answers are wrong. This is a passing problem now. X equals 3 has to be there. They didn't say which other values satisfy f of x equals 0, which they can, and they sometimes do. They just said which values. So x equals 3 is not there. So choice 2 and choice 4 are just not it. So the question is it -4 and 3 only, or is it plus or minus 3i and -4 and 3? And how can we do this? Well, there are a few options. One way, I'm going to, again, I told you that I is on your calculator. You could literally plug in I. And I'm going to show you that that's true. So the first, I'm going to plug in I. Because if 3i, I'm sorry, I'm not going to plug in I, I'm going to plug in 3i. Because if 3i is a root, -3i is also a root. And also choice 1 has to be wrong. So I'm going to plug in 3i. 3i, close parentheses. Again, I is above the decimal place in blue, so I press the blue second button, press I. 3i to the power of 4. Okay. Plus parentheses, 3i is in blue again above the decimal, so I press the blue second button, and then I. Close to the power of 3 minus 3 times 3i squared plus 9 times 3i minus 108. And if I get 0, now this is going to be important. If I get 0, I know that 3i is a root. And I got 0. I didn't necessarily expect me to get exactly 0, but there's a reason for that. That I didn't necessarily expect to get exactly 0. Because the calculator does have it uses what's called floating point arithmetic to do its math. So sometimes you get like a tiny, tiny, tiny decimal that comes out like an e to a power of negative something silly. But anyway, this proves Well, the point is that if you get e to a like 10, like whatever times e to the negative 8, that unfortunately for the calculator that means 0, even though in real life that doesn't mean 0. On the calculator it does. So that is 0. That means that 3i is a root of f of x. So f of 3i is equal to 0. And that confirms that this has to be the answer. But the way I said I would do this algebraically no matter what, and so I'm going to do it algebraically. I'm going to do this by, I can't factor this in any obvious way, for myself at least. So I'm going to do synthetic division. And I know that I will have done it right if the first two terms, because I'm going to start by dividing by x equals the root 3. Uh, and I know that 3 is a root. So I'm going to get 0 as the remainder. So I get 1, 3, 1 plus 3 is 4, times 3 is 12, plus negative 3 is 9, times 3 is 27, plus 9 is 36, times 3 is 108, plus negative 108 is 0. So that checks, which I needed to get 0, so I know I did it right. Now I'm going to divide this one by negative 4, or x plus 4. I get 1, negative 4, 0. And I already noticed that this is actually factorable by grouping, like the previous one was. I think this polynomial came up exactly with just negative signs in front before. Anyway, times 0, negative 4 is 0, plus 9 is 9, times negative 4 is negative 36, plus 36 is 0. And that checks because I know it's going to be a root. And now the factor pair is x squared plus 9, which is equal to x plus 3i times x minus 3i. This is perhaps relevant where I said that a squared plus b squared was not, I'm going to say p and q. If p squared plus q squared was not p plus q squared, or p squared plus q squared is actually equal to p plus qi times p minus qi. And if you don't believe it, multiply it out and you'll see. So here are the roots. X equals negative 3i for this one, and also x equals 3i, leaving choice 3 as the correct answer. Número 21, number 21. What is the remainder? Oh, no, sorry. The profit function. I was looking at 22, reading from the paper while I was looking at this. The profit function p of x is found by subtracting the cost function c of x from the revenue function r of x. And this is a very true function. The profit, this is actually always the case. P of x is equal to r of x minus c of x. Profit equals revenue minus cost. That is a classic economics equation that you actually are required to know all the way from Algebra 1 to Algebra 2. Which function below represents the cost function, given that p of x is equal to that expression, negative 15x squared plus 600x plus 60, and r of x is equal to negative 0.4x squared plus 130x plus 1200. Is it either one of these examples? C of x equals negative 14.6x squared plus 470x minus 1140, or C of x is equal to negative 14.6x squared plus 730x minus 1260, or C of x equals negative 14.6x squared minus 470x plus 1140, or C of x is equal to negative 14 is equal to 14.6x squared plus 730x minus 1260. So this is almost is this a 2x2 problem? Let's see. This when I was analyzing this one, this ended up being a part 2x2 problem, even though they're all four of them are actually somewhat different. Looking at the coefficients of the linear term and the constant term, that makes it a 2x2 problem. That said, how did I do this? So this one just requires us to know how to do the algebra for C of x. So you could either plug in P of x and R of x now and then solve for C of x, or you could actually solve C of x for C of x in this profit equals revenue minus cost function, and then plug in there. And that's actually the way I prefer to do it. So if I subtract R of x I get that P of x minus R of x is equal to negative C of x. And a lot of students, the reason there's pluses and minuses floating around everywhere is a lot of students miss that negative sign. If I multiply or divide by -1, I get that C of x is equal to R of x. So I could switch the order of the subtraction by after I divide by -1. So R of x minus P of x. And so that's the answer to the question. So let's see. At this point, I see that I'm going to subtract a negative. I got a small x squared, and I'm going to subtract a negative 15x squared. So I'm going to have a positive x squared term. So I'm already eliminating the ones with a negative x squared term. So choice 1 and choice 2 are not correct. These have a positive x squared term. So let's see. I got a negative parentheses. So I don't need the parentheses right now. So negative 0.4 x squared plus 130x plus 1200 minus parentheses minus 15x squared plus 600x plus 60 close parentheses. Keep keep the top number, change the minus to a plus, and change all of these signs inside. So, and then I get negative 0.4 plus 15 is 14.6 x squared. 130 minus 600, 130, yes, 130 minus 600 is minus 470 x. And then 1200 minus 60 is positive 1140, which leaves choice 3 as the correct answer. Could this one have been done by plugging in a number? Your favorite number? Yeah, yeah. Plug in x equals 0. That would have eliminated, that would have given you a cost of positive 1140, which eliminates all of them. Do you remember I said that this is a technically a 2x2 problem, but weird differences make it also possible that you could just eliminate all of them at once. If you just plugged in like x equals 0, yeah, you would have just gotten a positive 1140 as your cost, eliminating choice 1, 2, and 4. So you could do this problem by plugging in just any answer. Okay, what is the remainder when 4x cubed minus 3x plus 3 is divided by x minus 2? Now they are loving on this test the synthetic division stuff, or the division stuff in general. So I'm loving it because I love synthetic division. It's just such a clever algorithm. And by the way, the synthetic division algorithm, I know that it seems weird, but the synthetic division algorithm, it literally comes from long division. Once we realize that we're carrying a bunch of x cubed, x squared, x's in constant terms, or if there's higher powers, x to the fourth, x to the third, x to the second, we're just carrying those letters along. But really, what we're doing is using the arithmetic in front of them, and so that's all that synthetic division does is the arithmetic in front of them. Okay, so how do students get this question wrong? They miss that there's a plus 0x squared in the middle. Now, do I have to include the plus 0x squared when I'm doing synthetic division? Like, do I have to do it this way? 4, 0, negative 3, and 3. Yes. How do I prove that I have to do it that way? I could prove it this way. I always have to do the terms no matter what the coefficients. So if the coefficients were non-zero, would I have to use it? Yes. Which means, can I use it? Yes. Now, do I get a different answer if I do use it? Yes. Then if I don't use the 0x squared? Yes. So I have to use it. So, and then I divide by x equals 2. Now, as I promised, I would do every single problem by showing you a process of elimination. Dividing by x plus 2, the remainder is equal to the value of the polynomial when we plug in x equals 2. So I could literally just plug in x equals 2 and calculate the remainder. 4 times 2 cubed is minus 3 times 2 plus 3 is equal to 2, 4, 8, 6, and 32 minus 6 plus 3, which is equal to 33. No, which is equal to 29. But let's confirm it by the synthetic division, because I promised you I would do every single problem the way you could do it on a part 2. 4 times 2 is 8. 8 plus 0 is 8. Times 2 is 16. Plus negative 3 is 13. Times 2 is 26. Plus 3 is 29. What's that answer? Oh, and again, by plugging in, I just literally eliminated choice 1, 2, and 3 anyway. But I just confirmed it in 2 different ways. Not bad. Plugging in, plugging in, plugging in. That's the answer. The parabola, number 23, numero 23, the parabola with equation 12 parentheses y plus 1 equals parentheses x minus 4 squared has at 1, a vertex at 4, 2, or a focus at 4, negative 1, or a directrix y equals negative 4, or 4 units between the focus and the directrix. Okay, so this one talks about the focus and directrix and the vertex. Let's first talk about the vertex. It turns out that the vertex form of a parabola and the focus directrix form of a parabola have one thing in common. They both give you the vertex. And so the vertex, so in the vertex form, with the vertex, h comma k, is y is equal to a parentheses x minus h squared plus k. Y minus h and plus k. Remember what I said before earlier in the video, that the operations done to x have the opposite effect that an operation outside to f of x has. So adding k moves the graph up k, and if k is negative, maybe down a certain amount. But if you subtract from h, like x minus 5, that shifts it to the right in the positive direction 5. So x minus h shifts it to the right h. If h is negative, of course, itself, then it shifts it to the left. Minus a negative would be plus a number, right? Okay, so that's why there's a minus inside and a plus outside. Now the directrix form, focus directrix form, of a parabola with focal length P. Now this is a directed focal length. I should say directed focal length P. This is the difference between the focus and the vertex. Okay, focal length P, and then vertex h comma k, and then facing up or down. If it points left or right, you just switch the role of h and k. You get y minus k equals, no, that's wrong. I did this accidentally the other day when I was telling a student. You get x minus h squared equals 4p parentheses y minus k. Okay? So notice that the h and the k are both being subtracted here. Why are they both being subtracted here when the other one has it being added? Because k is not being added to y, k is being added to a times x minus h squared. If you subtract on the vertex form, if you notice, if you subtract on the vertex form, right, from k from both sides, you get y minus k. So that actually does make sense, that they'd be subtracting both. So in the focus directrix. So what does that mean? That means that the vertex can be read off is the number being subtracted from x is 4, and the number being subtracted from y is negative 1. y minus negative 1. So the vertex is 4, negative 1, not 4, 2. So that helps. Another thing you could have done is you could have plugged in x equals 4 and seeing if you got y equals 2. And that would have told you that the vertex couldn't be it because it's not a point on the parabola. Well, what about the focus for negative 1? I mean, we really, this is where we actually have to start actually adding details. Let's see. So x, y. So now the vertex is 4, negative 1. 1, 2, 3, 4, and negative 1. The vertex, so that's 4, negative 1. Okay. I'm going to put a V. Let's see. It's going to open upwards. So I'm going to put a V right there for vertex. Now I said 4p. So this here, 4p is equal to 12. Divide by 4, divide by 4. That means that p is equal to 3. The directed focal length is 3. So if I go up 3 units to 2, I get the focus is right there, 0.42. And the vertex is, so the focus is 4, 2, and then the vertex is 4, negative 1. So the focus is at 4, 2. That eliminates choice 2. All right, now the directrix. The directrix is 3 units down in the opposite direction from the focus. 1, 2, 3, negative 4. So the directrix is at y is equal to negative 4. Now, this all might be very new to all of you, but you know what? Follow it along. So this is looking good. Choice 3 is looking good. So what is special about the focus directrix form? What is the focus and the directrix? Well, the focus and directrix is the following. The points on the parabola are equidistant from the focus and the directrix. Notice that the vertex is 3 units below the focus and 3 units above the directrix. Every point on the parabola is the same distance from the focus and the directrix. So if I notice that the focus and the directrix are 6 units apart. So if I go 6 units to the right, 5, 6, 7, 8, 9, 10, 10, then that's another point on the parabola. Why is that? Because I know that this point is 6 units to the right of the focus and also 6 units away from the directrix. If I go to the left 6 units, I go to y x equals negative 2. I get another point on the parabola. And that point is 6 units to the left of the focus and 6 units above the directrix. So I have points on the parabola. This parabola is going to go like this. Now I put this that it passes through the origin, but I don't think it passes through the origin, does it? No, it comes close to the origin. It comes very close to the origin, but this is not exactly drawn to scale. 0, and we get y is equal to 16 over 12 minus 1, which is slightly over, just ever so slightly over the origin. Okay. So anyway, so now is 4 units between the focus and the vertex? Actually, no. The distance between the focus and the vertex, p equals 3. It's 3 units. So that eliminated that one. Okay, leaving choice 3. That might have been a completely new lesson for a lot of you. I know a lot of teachers don't bother covering the focus and directrix form of a parabola, but it is on Algebra 2. And so we just learned it. So if that's the first time you did it, I would definitely study that question especially and redo it because it absolutely can be on the Regents and there's no reason to think that it's not going to be. So I would redo that problem. Número 24, on the last multiple choice on this test. Now, before we get to the part twos, threes, and fours, there is a conversation that we need to have. Students and sometimes teachers tell students, focus on the part ones, focus on the part ones, focus on the part ones. Teachers aren't wrong-ish, aren't wrong-ish for giving that advice. I think, a lot of students just believe it. But here's the logic in quotation marks behind focusing on the multiple choice. The logic behind focusing on the multiple choice is that you only need 13 on this test, actually between 12 and 15 multiple choices to get a passing grade. And then if you get one or two problems on the part twos, threes, and fours, then you're almost guaranteed to pass. If you just get like a few, 12, let's say 11 multiple choices right. There's a certain amount of logic there, but the thing is that logic only works if you don't do work on the part ones. And the things that we've been talking about is, notice that if you're truly focusing on the part ones, you're showing work for the part ones. But if you're focusing on the part ones by showing work on the part ones and the part twos are identical to the part ones, then you're focusing on the part twos. So you could focus on the part twos by you could focus on the multiple choice by focusing on the part twos. The part ones are each 2 points. The part twos are each 2 points. So each part two is actually a multiple choice question. It's worth a multiple choice question. Each part three is worth 4 points. It means it's worth 2 multiple choice questions. And each part four is 6 points, which means it's worth 3 multiple choice questions. If you get all the points on a part four, you got 3 multiple choices free. And the beauty of the part twos, threes, and fours is that they all have partial credit. Part ones, you don't have partial credit. So you're not showing work on the part ones, which means you're not really focusing on the part ones. You're just doing the part ones. And then you're going to the part twos, threes, and fours and not doing them because they require work. But if you can't do them because they require work and you don't know how to do the work, you're not really focusing on the part ones. Which means that the thing is that the battle that your teacher's been having with you, focus on doing the work. You got to let them win. And if you don't agree with them, but you trust me, listen, I know you can do it. I believe in your ability to do really well on this test. But it does require you to be humble and do the best that you can and accept that showing work is the thing that you got to do. And you'll see that the part two, just like the part ones look like the part twos, threes, and fours, look like exactly like the part twos, look like half of the part threes, and look like a third of the part fours. You're going to see when we do the part twos, threes, and fours that we actually could just add multiple choices and they become part ones. That's it. The very last multiple choice, number 24, number 24. And every single question has had a way to eliminate some choices. So if you do appreciate that, because that's boosting your grade like crazy, almost every question became a passing problem. If you do appreciate that, please do hit that subscribe button or the like button. I do appreciate that. Again, this is free, but the way that I get paid for it is by your subscription. And I don't put out a lot of videos. I only put out math videos, so all you have to do is just not watch. But that said, Jay is training for a bike race over 15 weeks. This is number 24. But Jay is training for a bike race over 15 weeks. At the end of the first week, he has ridden 10 miles. Okay, that's a good ride. And he's planning to increase his weekly distance by 9% each week. It's a good increase. Approximately how many miles total will he have ridden from the beginning of his training to the end of his 15th week? So, is it 10.989 or 33.417 or 163.5 or 293.609? So this is the kind of thing that you have to, if you put a little bit of thought into the problem, you could actually do some quick elimination of choices. He's riding 10 miles on week one. At the end of the first week, he's riding 10 miles. And he's planning to increase his distance by 9%. He's planning to increase his distance by 9%, right? And we want to know the end of how much he rode in total, how many miles total he rides by the end of the 15th week. I mean, if he doesn't increase his total, 10 times 15 is equal to 150. Therefore, the answer has to be greater than 150. Passing problem, passing problem. A lot of students get this question wrong. Where do these choices come from? Why would a Regents maker ever add 10.989 and 33.417 into the choice? There's actually a very good reason. Despite the fact that those answers don't even make sense for the problem, in quotation marks, don't even make sense for the problem, there's actually very good reasons why those answers are there. It's actually a higher quality test because those answers are there. Here is the reason. When I was younger, they actually used to teach us to make estimates for the answer and make a guess, not a wild guess, make an educated guess if you didn't know how to do the problem. So you would estimate the answer just like I did 150, and then I would use that estimate 150 to make an estimate. So what would they do? They would add answers to the test questions. They would add answers that were just close to the correct answer, but couldn't be arrived at via any correct methods at all, to eliminate the ability of students to just estimate. However, if a student literally just learned how to do the problem, then on the multiple choices, when they used to do it that way, it was less likely that the uh, other answers would ever be arrived at when a student made a mistake. So by putting answers that were close to the correct answer but couldn't be arrived at by incorrect means, they actually created a test that was easier for students who did some basic math and knew how to do the problem. Now, the answers that they put in the test all have to be able to be arrived at via incorrect methods. Meaning that incorrect methods, meaning common errors that students would make. There are common errors that students would make that would give you either 10.989 or 33.417. For example, if you did 10 times 1.09 to the power of 15, one of those answers is there. I think it's choice 2. And yeah, and other things that you could do. I don't know exactly how you would get 10.989, but if you see choice 2 is there by an incorrect method, and then one of these answers, either choice 3 or choice 4, is now the answer. The fact that I did 150 as my answer, I happen to know that exponential functions actually tend to grow very fast. So my suspicion is that the answer is actually quite a bit greater than 150. So I'm liking this answer and I'm not liking that answer from my intuition of exponential functions. I have a base of 1.09 for 15 whole weeks. The rule of 72 says that the doubling time is approximately 72 divided by 9, which is 8 weeks. So after 8 weeks, he's already riding 20 miles. So if I add another, if I add 10 times 9, 10 times 8 plus another 20 times 7, now I'm actually at more than 163. So I've actually just confirmed that choice 3 is not the answer. And yes, I should have actually done, 10 times 8. Yes, so I did it right. And 10 times 8 plus 20 times 7 is actually still below the answer. This is still less than the answer. So the answer is less than 220. I'm sorry, 220 is less than the answer. So how do I do this? This answer is 10 plus 10 times 1.09. Okay, but then what about the third week? 10 times 1.09 times, I got to increase that previous week 10 times 1.09 but another 1.09, which is actually 10 times 1.09 squared plus another 10 times, well, the 1.09 squared, which is the previous week, times 1.09. So this is equal to 10 times 1.09 cubed. And now I'm getting a pattern, okay? So I get 10 plus 10 times 1.09 plus 10 times 1.09 squared plus 10 times 1.09 cubed plus dot 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 plus, now I got to get to the 15th week. Now this is where some students get a little off track. 1.09, the exponent, they're like 15th week, exponent is 15, but actually on the first week the exponent was on 1.09 was 0. On the second week the exponent was 1. On the third week the exponent was 2. On the fourth week the exponent was 3. On the fifth week the exponent is 4. So on the 15th week the exponent is 14. And I could put this all in my calculator, but actually, if I go to the formula sheet, that is a geometric series. So what is a geometric series? A geometric series is a sum of a geometric sequence. So 10 times 1.09, 10 times 1.09 squared, 10 times 1.09 cubed. If you notice from the formula sheet, that is a geometric sequence. So if I add those numbers, that's a geometric series. And according to this, I could actually add them up via this closed form expression. I got the sum of all of those 15 terms is equal to A1. So n is equal to 15. So I'm looking for S15. So the fact that I don't know S15 is good. A1 is equal to 10. R is equal to 1.09. N is equal to 15. I already got that. So I got this is equal to 10 minus 10 times 1.09 to the power of 15 divided by 1 minus parentheses 1.09. And you could ask the question, wait, 1 minus, I don't need parentheses around the 1.09 because that's just a number. 1.09. Hold on. Okay, 1.09. Okay, but now, and I said I'm an enemy of PEMDAS, by the way. What acronym do I prefer better? GEDMSA, where the G stands for grouping symbols. Because the horizontal fraction bar is a grouping symbol, but the diagonal fraction bar is not. So I will need parentheses when I put this in the calculator. I'm gonna get 293 and change, right? I already know that I've eliminated choice 1, 2, and 3. But of course, again, I need to know how to do this because this can easily be a part 2. So you could look on this big screen, but I'm going to put parentheses 10 minus 10 parentheses 1.09 close to the power of 15. Close that parentheses divided by the denominator 1 minus 1.09. Close parentheses. And I got that answer. Right below the right above the subscribe button. 293. So S15 is equal to 293.6091622. And they round it to the nearest thousandth. 293.609 according to the problem, which is my answer right there. Not bad. Multiple choices are finito. And not only that, we got them all right. 24 times 2 is 48 problems without even yet getting to the part 2s by showing work. What score do we have so far? 48 in our raw score. We already have a 78 without yet looking at the part 2s, 3s, and 4s. So is it worth looking at the part 2s, 3s, and 4s? Notice that if we only focus on the part 1s, we're capping our grade at 78. So we are not, like, here's the other, like, there's 1,000 arguments to focus on the entire test, not just the part 1s. But here's another one. If you're taking a test and you're like, I only have to get a third of the points right to pass the test, so I only need 25 out of 86, but you're not focusing on the part 2s, 3s, and 4s, you are not playing a game out of 86 points. You're playing a game out of 48 points. The maximum number of points you can get on the part 1s. And the passing grade for this test is a 26. I said a 25 earlier today, but it's a 26. I know I didn't. I said 26. So you're playing a game out of 26 out of 48. That is not 1/3 of the points. 26 out of 48 is around a 52%. You literally have to know how to do more than half the test to pass. So focusing on the part ones is not the way to go. Okay, so here is the instructions for the part twos. This one, you have to clearly indicate, again, 2 credit points, okay? 2 points each. You have to clearly indicate all necessary steps, clearly indicate all the necessary steps, including the appropriate formula, substitutions, diagrams, graphs, charts, okay? So that's a point. Utilize all of the information, and then look at this. Note the diagrams are not necessarily drawn to scale. I actually tutor my students to cross out the not necessarily and put almost definitely. They do it 5 times in the test, because in the cover page it says it, on the part ones it says it, on the part twos it says it, on the part threes it says it, on the part fours it says it. So they do it 5 times, 5 times. So also, what does it say? For all questions in the part, a correct numerical answer with no work shown will only receive 1 credit. So if you literally just give the numerical answer, so like you use your calculator, just give the numerical answer, you get credit. So if you don't know how to do the problem using correct algebra, do the test, do that on, do what you can on the calculator, give an answer, and you get 1 point. And remember, 1 point is half a multiple choice question. All right. Number 25, notice that this one could have a choice A, B, C, and D, or choice 1, 2, 3, and 4. This is absolutely a part 1 question. Given that x is a real number, write the expression in simplest a plus bi form. So we have to write it in that order. X plus 2i times 3 minus 2xi squared plus 2x squared I. So I have to multiply the x plus 2i with the 3 minus 2xi. So I make a grid. And then I put x plus 2i. And I put 3 minus 2xi. And then I add to this plus 2x squared I. So on the first box, I got 3x. On the second box, I get 6i. Just erase. Okay. 6i. On the third box, I get negative 2x squared I. And on the last box, I get negative 4xi squared. And then I could do my simplification as I write. So I got 3x plus 6i minus 2x squared I. There's nothing simplifying there. Now minus 4x, and now I have to know that I squared is negative 1. Again, we verified on the calculator that I squared is negative 1, right? But let's just do it again so you obsessively know it. I squared is negative 1, and might as well just add for edification purpose. I to the third is equal to negative I, and I to the fourth is equal to 1, okay? And of course, I to the first is equal to 1, and I to the power of I to the first is equal to I, and I to the 0, like any number to the 0 is equal to 1. It's also true for I, okay? So that's for your own complete education. Now I have to put the plus 2xi squared. My throat's super dry, I'm sorry. All right, that was Fairlife Milk number 1. Now I'm on Fairlife Milk number 2. All right. So to simplify, I noticed that minus 2xi squared and plus 2xi squared. I'm sorry. I miswrote this to begin with. Common error. Minus 2x squared I and plus 2x squared I cancel. That's great. So I got 3x minus 4x times -1. You know what? I'm going to restart this question. I'm going to restart this question, not from the box. I'm going to restart this question because I did mess up. And again, I'm not editing any mess ups, but I don't want to confuse you. Again, the important things to know: I to the fourth is 1, I to the third is -I to the second is -1, I to the first is I, and I to the zero is 1. But you can get that in the calculator to verify. Like if you ever get a problem, I like these kinds of problems. I to the power of 2024. Now you could actually do it on the calculator. Now this is an example where you have e to the -11. You have to know that e to the -11 is actually just 0 on the calculator. That has to do with floating point arithmetic, the way the calculator does it. So this is 1 plus 0i, which is 1. Okay, but that said, now I'm going to simplify this. Okay, I got 3x plus 6i minus 2x squared I. Now minus 4xi squared minus 4x I squared is -1, and then plus 2x squared I. Okay, now I notice that the minus 2x squared I and the plus 2x squared I cancel because I'm adding opposites. And so that simplifies nicely. So I got 3x plus 6i minus 4x times -1 is plus 4x. And now these like terms combine, I have 7x plus 6i. And it's in the order simplest a plus bi form. 7x plus 6i in that order. They love asking questions like this one. So we do want to know how to do this one. All right, número 26, number 26. Solve 3.8 e to the 1.5t equals 16 algebraically for t to the nearest hundredth. So I like to make estimates for this one, for this kind of problem. I got 4 times 4. If I round to 3.8 to the 4, then the other e to the 1.5t has to be around 4. 16. E is around 2.718. So e squared around 7. So that 1.5t might be around 1.5. So that t is approximately 1. So there's my estimate. I do teach my students to make estimates. Do you have to write this on the test? No. But that's my estimate. So my estimate right now is just 1. So let's see how close to my estimate I am. It does say algebraically. T appears exactly once in the problem, so I could solve it by eliminating all numbers by the inverse operation method. The last operation done to t is multiplication by 3.8. I could divide by 3.8, divide by 3.8. I'm going to leave it that way for now. You could put it in the calculator, and as I told you, I highly recommend putting the entirety of the decimals into the screen. So if you do decide to put this in the calculator, I recommend putting the entire decimal, 16 divided by 3.8. And then only when you're done, so you literally put 4.210526316, only when you're done would you round to what they said. But I'm going to leave it this way. E to the power of 1.5t is equal to, it's not approximately that, equal to 16 over 3.8. Now, how do I get rid of an e to a power? Like that's where you bring in the ln. So you do have to know that ln is the inverse of the exponentiating function with a base e. So that inverse of that, or you could equivalently think of it as bringing out the 1.5t, and then ln e is equal to 1. ln of e is equal to 1. Okay. So I got 1.5t is equal to ln of 16 over 3.8. And now I actually just have to divide by 1.5. And I got t is approximately, well, it's equal to ln of 16 over 3.8 divided by 1.5, but it's approximately equal to the decimal. It does say round to the nearest hundredth, so I'm going to round eventually. 16 over 3.8, close parentheses, divided by 1.5. Bring that here. Okay. So the muscle memory fixture is that I put all the decimals, 0.95839177703, And then I go back to the problem and see what they wanted, nearest hundredth, and t is approximately equal to 0.9 hundredth. The 8 causes us to round up. Okay. Five or above, round up. So 0.96. All right. Número 27, number 27. In an attempt to get the student body's opinion on a new dress code, members of the statistics class surveyed the students of the first period computer science class. Explain a statistical bias in the method of data collection. This answer allowed, almost by accident, more potential answers than any other question. But this is, in my opinion, a great example of a question where a student may be convinced that they don't know what to do on a part 2, 3, and 4, and then this question still gives them the partial credit. If you give a statistical bias and explain it, you get 2 points. So even if you don't know how to do this problem, you might see some flaws in the way they took the stats. But if you give just a statistical bias but don't explain why it's a bias, uh, then you only get 1 point. If you don't give a source of statistical bias, but you give a proper explanation given that source, you still can get a point. You actually, this one's way more partial credit friendly than you might suspect. So they're trying to get all the students' opinion on a new dress code. But then the members of the statistics class surveyed the students of only the first period class of only computer science. Explain a statistical bias in the method, and also they did mention new dress code, right? Only the first period, only computer science class. Explain a statistical bias in the method of data calculation. Any source of statistical bias will do. Only here's one. Only students in uh, computer science were polled. Um, Students in comp sci may feel different than other students in the student body. Done. I mean, literally. Any source of statistical bias. Other sources, they only surveyed students in the first period. Students during first period might feel different from students in later periods. Or this dress code is new. So I saw one answer that I didn't expect because it wasn't in the answer in the model responses. But one student said the dress code is new, so asking students in the first period hasn't let students become adjusted to the to or haven't allowed students to assess how they felt about the dress code yet. I mean, done. See, because in my interpretation, new meant maybe last week or something like that. But new could have literally been this is the very first period at all. And this is not clearly expressed in the problem. But so that's a valid expression based on the wording of the problem. And so that was a 2 point answer. Okay, this one has three answers. Número 28, number 28. Uh, Sketch the graph of polynomial p of x on the set of axes in the next page. Given the criteria below, p of x has a 0 only at -5, 1, and 4. I'm sorry, it has more than two answers, I should say. P of x has a 0 only at -5, 1, and 4. As x approaches infinity, p of x uh, approaches negative infinity, and as x approaches infinity, as x approaches negative infinity, p of x approaches negative infinity. So I said that this one has only two answers. Really, this one only has, I'm sorry, three answers. Really, this one has only three answers that look like a quartic polynomial. But if you allow it to look like any other polynomial, that's actually perfectly fine. And the truth is that they are very friendly in terms of not requiring it to be like a quartic, and that's really necessary because the size of hills, and things like that might not um, be uh, appropriate for a specific polynomial. But here is a thing that a lot of students would do to get some intuition. A lot of high level students would do to get some intuition on the problem. So if you consider yourself not a high level student, which I would consider why and what you could do now to change from a low level student to a medium level student in like one shot, because often there's just habits of mind that you could take. Like, for example, showing work is one of them, but also, you know, using operations only when things are legal, doing things that are legal, and also starting to observe what operations are illegal and not doing those. Okay. So one thing you could do, if you know the roots are -5, 1, and 4 only, you could start with a polynomial that has roots -5, so x plus 5, and x minus 1, and x plus 4. No, minus 4, rather. Okay. And then I could literally just see if I could expand this a little bit for you. I could literally just graph this and see if that's something valid. Now, this one, I have to zoom out a little bit. Zoom out. Um, I'm gonna change my window, which is a risk. But if you change your window and it starts looking ugly to you, you could literally just go zoom standard to reset all of that. So I'm gonna change my y min to like -50 and my y max to +50. Now I'm gonna graph this, and I see that this function blows upward in the wrong direction as x approaches positive infinity. This one says as x approaches positive infinity, p of x approaches negative infinity. Okay? So it fails. The one that I just drew, ugh, so I shouldn't do Control Z. I hate doing Control Z, but I have a habit. Okay, it failed that one. So one thing you could do for your drawing is actually just start off, draw that, because you know it's going to blow up in the negative direction. And one thing you could do is start putting the roots in 1, 2, 3, 4, -5, and 1, and 2, 3, 4. And those are the roots, and those are the only roots. Now I'm going to change this to blue. Okay. So I'm going to change my graph. Why did that? Go that way and that way because I know it's going to blow up that way. So now I have actually partially my graph. Now I have to go through 3 points, but I have to go down somehow. Something interesting has to happen. What if I actually go to my graph and I square one of these? I'm going to square x minus 4. Now I have a graph that blows up in the positive direction for both x and y. But now what if I actually negate both of these? If I negate everything. So now I actually have a polynomial with a negative sign here. Now I notice that it actually bounces off of x equals -4. So I connect that to this. So how I did that, I connected that. And then I go through at x equals 1. And then I go through at x equals 5, -5. And I connect it to that. This slightly sloppy graph, I have to redo that because it kind of had a little nub there, is perfectly valid. That you can't use a straight edge. Okay. Okay. You can't use a straight edge to do your graph because the graph is a polynomial that's curvy. If you did use a straight edge, you'd actually lose points there. But so because you can't use a straight edge, they actually expect your handwriting to be a little bit. Look at my handwriting. I mean, my hand doesn't really do this, but you can't keep your hand perfectly still to draw perfect curves like technology can. So this is actually a valid answer. Notice that one of them, it has to bounce off one of these roots. At least one. So another possibility is the same deal. 1, 2, 3, 4, -5, 1, and 4 is, what if it doesn't bounce off of the -4 over the +4? What if it bounces off at x equals 5? Okay, so what, -5 rather, what if it, so it bounces off here and it does that? And there's more than 3 answers. I should say there's more than 3 answers. This and this. That's another answer. And then finally, what if it bounces off only at -1? 1, 2, 3, 4, -5. 1, 2, 3, 4. Does neatness count on these graphs? I don't want you to think that if my graphs are a little bit jagged, that the neatness doesn't count. It actually counts extremely well. Like if your roots are not clearly at a -5, 1, and 4, you're not going to get credit for that part. So another thing is if your graphs are not curvy, like if they accidentally have little corners, and polynomials don't have corners. If they have corners, you're going to lose points. So those are places where you can lose points. So here it can blow up in a negative direction, go up, maybe it could bounce off of x equals 1, and it can go through. And let's try that again because I almost missed. So it bounces off smoothly off of 1 and then goes smoothly through 4. Notice the bounce here. It didn't go like at 1. It didn't do that and that. If you did that, that's interesting. If you did that, I need to make it a handwritten V. If you did that and then that is not a polynomial because it comes out at a V. So polynomials come out smooth, so you have to draw that smoothly. Okay? Now, like I said, there are more than one answer, more than just these answers. You could have also gotten something like this. This one's a rough graph. This one has to be, this one might not be full credit, but you could bounce off that, stay under, bounce off that, stay under, bounce off that, stay under. That's an answer that I didn't see on any, not even a single test that I graded, but it is a valid polynomial. Something like, y equals -x minus 5 squared, x plus 5 squared, x minus 1 squared, x minus 4 squared, something like that. Yeah, so there are a lot of answers. You could have put some jiggliness because of other factors. I mean, there's a lot of, this one had a lot of flexibility to it. And which, because of that, I mean, an enormous amount of partial credit. All right, that's it. Number 29, number 29. So the height above ground of a Ferris wheel car can be modeled by the function h of t equals -103.5 cosine 2 pi t over 5 plus 108.5, where h is measured in feet and t is measured in minutes. State the period of the function and describe what the period represents in this context. So if you have a function h of t equals, let's say, negative a times cos bt plus d, a is equal to the amplitude. Actually, I'm going to take out the negative sign and put this absolute a is equal to the amplitude. B is equal to the frequency. And D is equal to the vertical shift. And it happens to be that there's a nice equation. The frequency is equal to 2 pi over the period. Now, I will say this, that the frequency in math class is actually corresponds to what's called the angular frequency in physics. But okay. So we have this equation. So this equation is going to allow us to get the period. So state the period of the function and describe what the period means. So if you say 2 pi over 5 is equal to 2 pi, I'm going to say let p equal the period. 2 pi over p. Students love the cross multiplying, and I used to hate cross multiplying, but it actually, tutoring wise, fixed a lot of issues. So now I love tutoring. Now I love tutoring with the cross multiplication. So 2 pi p, just try to remove the erase. 2 pi p is equal to 2 pi times 5. If I divide by 2 pi, divide by 2 pi, that cancels, that cancels, that cancels. I got that p is equal to 5. Okay, so now what does that mean? The period is the amount of time that it takes for the cosine function to go through one cycle. So now I have to go back into the problem and see what the cosine function represents. Because if you just say that the period represents the amount of time it takes for the cosine to go through one cycle, I don't think they'll give you credit. You might get a lucky grader and they'll give you credit, but you'd have to be very lucky, because I would not. That's not a 1 point explanation. So h of t is measured in feet, and that's the height of the above the ground of the Ferris wheel. So the period is the amount of time for the cosine to go back to where it started. Well, that means that it's the time that it takes for the Ferris wheel to go back to where it started, or equivalently, that the amount of time it takes for the Ferris wheel to make one full turn. So p equals 5 is the number of minutes it takes for the Ferris wheel to make one full turn. Notice that this is actually a friendly partial credit problem. If you get the period correct, phenomenal. If you didn't get the period correct, maybe you made an algebraic mistake or used an incorrect formula, but then you actually gave, based on your number, a correct explanation. That's a point. So this is a 1 + 1 point question. Literally 1 point for the period, 1 point for the explanation. Notice that my period has no units in it. If they give the units, you don't have to give the units. And they did say that t is measured in minutes. Okay, so p equals 5 means that the period is 5 minutes. Okay, so numero 30, number 30, solve algebraically for all values of x. And I hope that this video is helping you guys. I know that these videos can be long and you're making the effort. Look, we're way over 3 hours. We're almost hitting 4 hours into this video, and you are seriously making a concerted effort to do the best that you can. So I really do appreciate the effort that you're making. The key is just keep at it. Do understand how I got the answers, and I highly suggest writing down the method that I used. If you write down the method that I used, the muscle memory will help you to pass the test. Okay. So I'll solve algebraically for all values of x. So I can note now that I'm dividing by x plus 5 and I'm dividing by x, so x can't be 0 or -5. Because of that, because there are possible answers that are illegal, I am required to check my answer, to check for undefined points. So I am required to check my final answers. Remember that. So I'm going to eliminate the denominator. I'm going to multiply by x plus 5. I'm going to multiply this by x plus 5. As we do, get a common denominator, multiply this by x plus 5. And I get, well, with this one, the x plus 5 cancels. With this one, the x cancels. And with this one, none of them cancel. So I get 8x minus 3, parentheses, x plus 5 equals 5x parentheses x plus 5. I'm going to use my distributive property. So I got 8x minus 3x minus 15 equals 5x squared plus 25x. Okay, so you may wonder what counts as an algebraic solution. You could solve this algebraically by factoring, or you could solve this algebraically by using the quadratic formula. There was a question among teachers in my school whether quadratic formula qualifies as an algebraic method or not. But looking at the way the problem is graded, they allow the quadratic formula. So the quadratic formula is a algebraic method. 5x minus 15 equals 5x squared plus 25x. I'm going to subtract 15. No, subtract 5x. Minus 5x. I'm also going to add 15 right now. I'm going to move this over a little bit. I got 5x squared plus 20x plus 15 is equal to 0. I could factor out a 5, x squared plus 4x plus 3. And actually, I see that this one should factor. Blank plus blank equals 4, and blank times blank equals 3. 1 plus 3 is 4, and 1 times 3 is 4. So this one factors nicely. I got 5 parentheses x minus 1 times, no, x plus 1 times x plus 3 equals 0. Factor method, the zero product property implies that one of the factors is equal to 0. So 5 equals 0, never. X plus 1 equals 0, minus 1 minus 1. The x equals -1. And x plus 3 equals 0, minus 3 minus 3. You got x equals -3. Now, let's not forget that we have to check our answers. How do we check our answers? Well, the only answers that make the original undefined is dividing by 0. We divide by 0 if x equals actual 0 or x equals -5. So therefore, the solutions and x equals -3 are both valid. So those are our answers. And they often make it. They actually, and this is Algebra 2. I'm actually extremely shocked that they actually made it a problem where you didn't, where the both answers were valid. They almost always, more than 90% of the time, make it so that one of the answers is not valid. And maybe a few times they make it so that both answers are not valid, really rare. But usually they make it one answer is not valid. And I'm trying to remember a single time where they made it so that both answers were valid. All right. Numero 31, number 31. The transportation methods used by the upper class men at Calhoun High School, Long Island, are summarized in the table below. upperclassmen transportation methods, junior, senior, drive, take the bus, walk. And I see the numbers. I do read the numbers real quick and then I move on, then I come back. So I see 58, 75, 12, 81, 39, 12. Are the events being a junior and driving to school independent? Use statistical evidence to justify your answer. So you have to know what this means, independent. It's not necessarily obvious what it means, because how do you turn a statement about like logical, which you know what it means to be independent, like one outcome doesn't affect the other outcome, and turn it into a mathematical statement? So statements, I'm going to call this J. Let J equal the event being a junior. And let D be the event driving to school. So there's three equivalent definitions of independent events. The one that I'm a fan of tends to be the one that's not used almost ever. So I am going to use the one that is used more often, unfortunately. But the one that I'm a fan of is, I like it a lot better. So J and D are independent if and only if any of the three equivalent, the three, following independent equivalent statements hold. Okay, I'm going to give my favorite. The probability of J being a junior and being a driver is, I missed the P. The probability of being a junior and driving is equal to the probability of being a junior times the probability of driving. That's my favorite, and that's equivalent to the other two. But how is it normally given? The probability of being a junior is equal to being the probability of being a junior given that you're driving. Or again, I'm going to write this in words. The probability of being a junior given that you're driving. And what does that mean, by the way? You're only looking at junior given that you're driving. You're only looking at the drivers, and out of that fraction, what's the probability that you're a junior? And then the third one is the other way around. The probability that you're a driver is equal to the probability that you're a driver given that you're a junior. Or in other words, the probability that you're a driver given that you're a junior. And so what's this one? This one would be you're only looking at the juniors, and within that fraction, you're looking at the probability that you're a driver and comparing that to the full probability that you're a driver. So any of these three statements hold. And vice versa, if any of those three statements don't hold, then the events are not independent. In other words, they're dependent. I'm going to use this one because that's the most commonly used one. However, the one that I like is the first one, because that one's just, for me, easier to calculate. But that's not the way it's usually done. So the probability of being a junior is equal to, well, the junior, you look at the part that's a junior over the whole class, which is equal to the numerator, 58 plus 75 plus 12 over 81 Nope, it's the whole class now. 58 plus 75 plus 12 plus 81 plus 39 plus 12, which simplifies to, according to my calculator, 145 over 277. And I did do that on my calculator, and I did check to see if I could simplify that fraction. And that's important because you want to have the simplified fraction. So let's actually do that. So 145 over 277 math, convert to a fraction. I didn't mention this before, but convert to a fraction doesn't just convert it to a fraction, but it converts it into a fraction in lowest terms. But it's still 145 over 277. So that's simplified. The benefit of that is that if you have two simplified fractions, they're equal. They look equal. They're written the same numbers. Whereas if you have two unsimplified fractions, they could just look weird in lowest terms. Okay. Now the probability of being a junior, given that you're a driver, is equal to the part of the drivers who are J, are juniors, divided by the whole, which is the drivers. Which is equal in this case, the part of the drivers who are junior is only 58. This is already looking bad for the other one. 58 plus 81, which is equal to 58 over 139. And again, in my calculator, 58 over 139, convert that to a fraction in lowest terms, is just 58 over 139 in lowest terms. And here, 145 over 277 does not equal 58 over 139 because two fractions in lowest terms have to be literally the same written fraction. These numbers, 145 and 58, are literally not the same number. 277 and 139 are literally not the same number. So the probability of being a junior is not equal to the probability of being a junior given that you're a driver. That's a vertical line. So junior and being a driver are not independent. Yeah, that's how to do that one. I know that this is a new lesson for a lot of people, but it is a commonly asked question. It is a commonly asked question. So we do want to know how to do that, okay? And somehow, with all that work, it's a part 2 question, meaning it's worth 2 points. So how could it possibly be worth 2 points? Well, if you get one of the probabilities correct, you get a point. And of course, you don't have to write everything that I just wrote because I had to teach you what the stuff meant, which is what caused me to have to write so much. But número 32, number 32, can f of x equals x cubed plus 7 be classified as an odd function? Justify your answer. So we have to know what an odd function is. Now, an odd polynomial is a polynomial where all terms have odd powers of x in standard form. An even polynomial is a polynomial with all the exponents are even in standard form. But then what is an odd function? So it turns out that even functions satisfy certain symmetries, even polynomials satisfy certain symmetries, and odd polynomials satisfy certain symmetries. And those symmetries are what are attached to the definition of an odd function. So f of x is an odd function if f of negative x, I got to replace x with negative x, is equal to negative f of x. Now, I have to, just for completeness sake, I have to define an even function. F of x is an even function if f of negative x is equal to positive f of x. Huh, the undo button works weird. So that's why I've been having problems with the undo button. I literally pressed undo and it deleted one of the last curves I wrote. Interesting. So f of negative x equals positive f of x. So clearly we are looking for f of x being an odd function. So we have to replace x with negative x. F of negative x is equal to negative, don't use undo, negative x cubed plus 7, which is equal to negative x cubed. So -1 times -1 times -1, according to my calculator, is -1. So negative x times negative x times negative x is negative x cubed plus 7. Okay? Whereas negative f of x is equal to negative parentheses x cubed plus 7. And this is where a lot of students mess up. A lot of students get this question wrong because they don't distribute or they don't use they don't use parentheses at all. First, they don't use parentheses, so they get points off. Second, they do use parentheses, but they don't distribute properly, so they get the same answer that a student who doesn't use parentheses at all does. When you distribute, you have to distribute over the entire addition, so you get negative x cubed minus 7, which is not the same thing as negative x cubed plus 7. So we got f of negative x is not equal to negative f of x. So f of x is not an odd function. Okay, if you just learned what even function or an odd function is, please do hit that subscribe button because I just got you literally 2 points on the Regents. Number 3 though, part 3 though, we are finally up to the part 3s, and we see that each one will receive 4 credits. You can mess up fairly royally on this question and still get partial credit. I don't know what it is. Like I must have like if you remember, there was a question that I said I messed up like a whole bunch of times while I was doing that question. This is another question that I messed up personally while I was doing this question just a lot of times. A lot of times. So I'm surprised that they made a question as difficult as this one for a system of 3 equations with 3 unknowns. Normally speaking, they make it so that some of the variables cancel nicely. But in this case, they made it so that that's just not the case. So I'm going to go ahead and call this, they did say algebraically. So if you happen to know matrix methods, that actually counts as algebraic. However, most of you don't know like matrix methods because you didn't take a combined Algebra 2 / pre-calc class. This one, I'm going to call this one R1 for row 1. Call this one R2, row 2. Call this one R3, row 3. So I noticed that none of the coefficients match for me to do some quick and easy subtraction. So what I'm going to do, I noticed that I can cancel. I noticed that but with row 1 and row 3, so I guess maybe this is an easy subtraction. I noticed that row 1 and row 3, if I look at the coefficients of x and z, those actually cancel out somewhat very nicely if I combine them, a multiple of them. So if I do row 3, which is negative 6x plus 2y minus 4z equals 36. So you'd have to notice this. Okay. And if I add 2 times row 1, I get 6x minus 16y plus 4z equals negative 120. If I add these together, I actually get 0x, which x canceled, minus 14y plus 0z, which is great, that cancels, equals negative 120 plus 36 is negative 84. So I got negative 14y equals negative 84. I divide by negative 14, divide by negative 14, and I get that y is equal to 6. Negative 84 divided by negative 14. Do I use my calculator here? 100%. Absolutely. Absolutely. Okay. So I got y for free, which I mean in one step, which is nice. Now I'm actually going to use row 2 and row 3 to get one more variable. If I notice row 2 and row 3, uh, the x's have a, well, 2 times 3 is 6. So if I, 2x times 3 is 6x. So if I multiply row 2 by 3 and add it to row, if I multiply row 2 by 3 and add it to row 3, I cancel out the x. I already have y, so that's good. So I got 3 times row 2, which I got 6x, minus 21 times y, which is already 6. I'm going to leave the y in there for a second. Okay. 21y minus 15z equals negative 93. And I'm going to put row 3. I got negative 6x. That's going to cancel. Plus 2y minus 4z equals 36. I'm going to add these together. That's going to cancel out my x. I got 0x minus 19y. Just making sure that I did this right so far. I did. Okay. Minus 19z equals negative 93 plus 36. I'm doing this on my calculator. I should get negative 57. This is me and my carefulness. You want to obsessively use your calculator here. It might feel like it makes it last longer, but honestly, every arithmetic error that you could possibly make rears its ugly head on a system of 3 equations with 3 unknowns. Every pre-calc student knows that. They get to this and they're like, oh, but I don't worry. And then they do one problem and like 4/5 of the class gets it wrong every single time, but royally. Because if there's an error that they're prone to make, they make it. So negative 57. And I said that we already know y. So I'm going to replace the y with a 6. And I get that negative negative 19 times 6. That's me being careful. Negative 114 minus 19z equals negative 57 plus 114 plus 114. I get negative 19z equals actually positive 57. Divide by negative 19. Divide by negative 19. I get that z equals let's see. I got z equals negative 3 or positive 3. This is where I'm going to check my answers. I literally, this problem is insane. I agree that problem is insane, but it is a fair question to ask. I just want to be super careful. Page 49. Negative 3. Okay. I got scared for a second because in my notes, you see, I have positive 3, even though I know that that's negative 3. Okay. So that was insane. Now I have to get x. Now that I have that, I'm gonna go and get x. So I could get that with any of the rows. I'm gonna get it with row 1. And I'm gonna confirm my answer. Okay. Row 1. I get 3x minus 8 times 6 plus 2 times negative 3 equals negative 60. Okay, so I got 3x minus 48 minus 6 equals negative 60 plus 6 plus 6. I got 3x minus 48 equals negative 54 plus 48 plus 48. I got 3x equals negative 6. Divide by 3. Divide by 3. X equals negative 2. Let's just confirm that I didn't lead you astray. 6, negative 3, negative 2. 6, negative 3, negative 2. I'm tempted to check my calculator to see what I had gotten earlier. And did I do it on this calculator? Yes, I did. I got the same exact answers. 6, negative 3, negative 2. So those are our answers for X. It's a monster problem. I know that you might be saying to yourself, is it worth my time to do it? But did that take us about double the amount of time that a multiple choice question took? Actually, yes. And the biggest deal is, unlike multiple choice is either a yes or a no. Did you get it right or not? This allows for an insane amount of partial credit. If you got the wrong answer, let's say for example for Y, like my work that because I made a few errors, but they actually correspond to the same errors. I just kept doing the same thing over and over, and for some reason my coffee must have run out. It was like 10:30 at night watching TV. Maybe I got distracted by a cool scene on TV. I got the wrong answer for Y, which led me for a wrong answer for Z, which led me to a wrong answer for X. And by coincidence, my answers were integers, which made me think, oh, maybe I'm right. I only lost 1 point. I would have only lost 1 point if I had gotten the answer that I got, because I made the same error multiple times. But when I went to fix it, I kept also making an error. Then I fixed it and made it. It was just weird. It was just weird. What happens sometimes when I make a mistake, that just happens that way. That's how I am. So, número 34, number 34. The town of Skaneateles. I don't even know if I'm pronouncing that right. Skaneateles. I'm sorry for people who live in Skaneateles if I didn't pronounce it right. New York. Skaneateles, New York. House prices since 2008 have changed based on the function h of t equals 200,000 times 1.045 to the t, where t is the number of years since 2008, and h of t is the median house price. Determine the average rate of change for the median house price in Skaneateles from 2010 to 2018 to the nearest dollar per year. This is one of those examples where I told you I highly recommend writing the full answer from the decimals and then rounding to what they said. So they want the median house price, the average rate of change. This is from 2010 to 2018. You do have to know that this is t equals 2, and this is t equals 10. So this is h of 10 minus h of 2 over 10 minus 2. So that's the calculation we have to do, equals 200,000 times 1.045 to the power of 10 minus 200,000, 1.045 to the power of 2, and divided by 10 minus 2. Now, I told you I like doing estimates. My estimate, if the rate of change is 4.5% at year 2008, and only 10 years have passed, well, at 10 years, the average rate of change might be, at 10 years, might be pretty big, but the average rate of change, the average of those rates of change between year 2 and year 10, might not change that much. So my estimate, I just will use the estimate from year 0, 4.5% of 200,000. So 0.045 times 200,000, that's 0.09. Move the decimal place over, 1, 2, 3, 4, 5. 0.045. Move the decimal place over 0.09. Yeah, move the decimal place over 5 times. And we get 9,000. So the answer is going to be a bit bigger than 9,000. When I say a bit bigger, I mean a little bigger. So that's my estimate. I'm going to take my estimate and let's see where I am. Now, again, grouping symbol, the horizontal fraction bar is a grouping symbol, the diagonal fraction bar is not. So you do need parentheses. If you make that arithmetic error, on that algebraic error, not using parentheses around the numerator and denominator, that unfortunately is considered to be a conceptual error, which could lose you half the credits for that section. So the first section, half the credits of 2 is 1. So you do need parentheses around the numerator, 200,000 times 1.045 to the power of 10 minus 200,000 times 1.045 to the power of 2, close parentheses, divided by 10 minus 2. I noticed I did not put parentheses around the 1.045. You're not required to put parentheses around a positive number. That was just a thing that just happened to do for that one. Maybe as I was typing. But if you do want the parentheses, you could totally insert them. Above the delete button is blue insert. Press parentheses. And then above the delete button is blue insert. So I press the blue insert button. Oops. Press enter. And now, as you recall, I recommend adding all of the decimals and then rounding, as they said, to fix muscle memory. So this is the average rate of change is equal to that, and so this is equal to, or rather approximately equal to, 11523.61054, and then I go to the nearest dollar, 11523. Nope, 11524. 6 and above, 5 or above. So I round this up. Okay, so 11524. Notice that they actually gave me the units, dollars per year. They gave me the units, dollars per year, so I don't have to give the units. And in fact, they'll almost always give you the units. And I do have to check that they gave me the right units. H of T is in dollars, and T is in years, and they asked for rate of change in dollars per year. So they did use the correct units. The next one, explain what the rate of change means as it relates to the median house prices. A lot of students would say that the house price is changing at exactly that amount, but no, this is the average rate of change. So this means that house prices, median house prices, are changing, increased, an average of about 11524 per year. During the years 2010 to 2018. 4 points. So far, we've gotten every single point on the test. Every single point on the test. So we are literally a few seconds away from getting 100 on this Regents, which is super. We have 2 more 4-point problems and a 6-point problem. And so we're literally already almost acing the test, which is amazing, amazing. But one thing I do want to show you is about the scoring. All of that work, how many points did that get us? So we have already problem 35, 36, and 37 blank. That's 4 points, 4 points, and 6 points. That's 14 points. So if you subtract 14 points from the raw score, 86 down to 72, that's an 88. That's a really great score in 88. But if you remember, if we do every single multiple choice question correctly, we get a 78. All of that extra work that we did in the part 2s and 3s got us 10 more points on the Regents grade. But and now you might say, wait, but doesn't that imply that it's not worth doing that? Well, this is another proof that it is worth doing that. If you stake 48 and you subtract those same 14 points that we haven't gotten yet down to 34, now we're to 71. And at 71, now we are playing with fire in terms of passing. So every single point that we get on this test is extremely vital. Extremely vital. Okay? So, number 35, a sporting goods manufacturer is trying to determine if they should continue to produce multiple types of hockey pucks. The company surveyed 50 randomly chosen customers and asked them if they purchased both game regulation pucks and lighter training pucks. Of those surveyed, 40 of them said that they purchased both types of pucks. A simulation that was run 100 times based on the survey results produced approximately normal results below. And I would immediately look at that. I do look at the table, then I move on and then I come back to it. I see mean 0.795 and SD 0.085, standard deviation 0.085. I see some numbers 10, 20, 30 in proportions from 0.56 to 0.96, proportion that purchase both types of hockey pucks. Then determine an interval containing the middle 95% of plausible values that estimate the proportion of all customers who would purchase both types of pucks from the company. Okay, so this question, again, if you remember the 68, 95, 99.7 rule, again, so 68% of data is within one standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean, and 99.7% of the data is within 3 standard deviations of the mean. So they said the middle 95%, which is almost always what they'll ask for, that's this over here. 2 standard deviations of the mean. So we need to find the interval, the mean minus 2 times the standard deviation, and then the mean plus 2 times the standard deviation. So this is equal to, for this problem, 0.795 minus 2 times 0.085, comma 0.795 plus 2 times 0.085. And then I go to my calculator and make sure I don't do this arithmetic incorrectly. And I get 0.625, comma 0.9, and I think I wrote a 6 and wrote 4 over it, or I wrote a 4 and wrote 6 over it. And let's see, 0.625 plus 2 times 0.085. That's 9. That's, nope. Why did I write that? Oh, the 625. I know I wrote it. I read the wrong number. 795.965. Good. And then letter B. The company will continue to manufacture both types of hockey pucks if it is reasonable to assume that the true proportion of customers who buy both types of hockey pucks is above 0.60. Using the interval from part A, explain whether or not the company should continue to produce both types of hockey pucks. So according to this, you notice that 0.60 is not in the 95% interval. So it is reasonable that families will continue to buy both types of hockey pucks. And that's what we have to say. The 95% confidence interval above is above 0.60. So the company should continue to make both pucks. Both pucks. And that is a 4-point question. 4-point question. Número 36, number 36. So this is a question that a lot of students lose points on because they don't create a neat graph. So neatness counts when it comes to graphs, and I want you to just remember that. Neatness counts when it comes to graphs. You can't get sloppy with graphs. Notice that my handwriting is not the best handwriting. And I have worked on my handwriting. It's just for some reason my handwriting does stay a bit sloppy. So and I it's a thing. So but I promise you that I am doing my best. Writing sloppy because I'm not making the effort is a different story from writing sloppy because I have some handwriting issue. So then the point is, like, if you write the letter A like that, and your A sometimes looks like that, and so your A sometimes look like a C, or so the A looks like a U. Like, but if you're writing words, notice my words are. I mean, that R almost looks like a dash if it was all by itself, right? Or a checkbox. I don't know. But if you're writing words, we can read your words. But what's the problem? A graph is not just about seeing a curve. It's about the graph itself having meaning. So when you produce a graph, you have to write what you mean. So how do we go about doing that? We can do that by, well, we have to know what the graph actually looks like. And unfortunately, this calculator is not going to give us all the details that we would want for the graph of the natural log, or I'm sorry, the log base 2. So you have to know that the log base 2 has an asymptote. And since it's at the log base 2 of x has an asymptote on the y-axis. So the asymptote of log base 2 of x minus 1 is moved to the right one space. So it's at x equals 1. And then if you add 3, well, a vertical line x equals 1 shifted up 3 spaces is still at x equals 1, right? But can you do this on the calculator? Math, number, where is log base? Okay, actually, if you press the math button, one of the last options is log base. So log base 2 of parentheses x minus 1, close parentheses, plus 3. And I'm going to go to the table now. Now I make it so I can scroll. I see errors below x equals 1, which makes sense because this has a vertical asymptote at x equals 1. As I said, you do have to know that. If we look at the graph, we're going to graph it in a second. Unfortunately, the graph is not super detailed enough, but notice that my line is dotted. Now, do I have to graph that line with a straight edge? Yes. I had to do it by hand because my software doesn't allow me to draw dotted lines with a straight edge, unfortunately. So I had to do it by hand, but yes, you have to do it with a straight edge. But what about the curve, the function? Do I have to do that one with a straight edge? Actually, no. That's a good thing. And in fact, you're not allowed to graph curves that are not straight with a straight edge. So 2, 3 is another point on the graph. 2, 3, 3, 4, and 5, 5. 3, 4, and 5, 5. And if I scroll down, I should see that 9, 8, 9, 6 is also a point. And in fact, 9, 6 is also a point. Now, if I graph it, I have to go back to Zoom Standard. Zoom Standard is number 6. I see this almost square root-ish graph, but it's not obvious that there's an asymptote here, and there is. So you do have to know that there's an asymptote. I'm going to graph this curve. I'm going to graph it again because I want to make sure I go through every single point. At the corner, perfect. But now I have to know that there's an asymptote, so I have to get closer to that curve. And yes, it's expected that my hand's going to jiggle a little bit. Now, the second thing I'm going to do is put the arrows. There are technical rules to when you use the arrows. If the graph continues forever, you should use arrows. If the graph actually ends, period, then you don't put arrows, okay? You can get away with not using arrows in certain cases, but the thing is, I don't even want to tell you what those cases are in the case of not showing work. You have to not use arrows if the function ends at a single point. And there are certain situations where you might have a graph that looks like this, just ends. But if this one happens to go down forever, you have to use an arrow, okay? I almost don't want to address the places where you're allowed to not use the arrows. But I would say this, if the graph also continues all the way past the end of the board, graph it past the end of the board. This is a 2-point graph. Now, state the equation of the asymptote, x equals 1. Just state the equation of the asymptote. I've stated the equation of the asymptote, x equals 1. Now, when f of x is reflected over the line y equals x, a new function is formed. I should stop using the undo button when I really don't need it. When the f of x is reflected over the line y equals x, a new function is formed. G of x equals 2 to the x minus 3 plus 1. State the equation of the asymptote of g of x. So one thing that I can do, I could literally graph that. I'm out of function, so I'm going to graph it at 1. So 2 to the power of x minus 3 plus 1. Now, those of you who are comfortable with inverse functions, this makes the inverse function. In other words, if you take a function and reflect it over the line y equals x, the function that the relation that you graph is the inverse relation. In this case, the inverse relation is a function, so the graph is the inverse function. So this is the inverse function. If you know that, you may know already what the asymptote is. When you see the asymptote looks like it's at y equals 1, horizontal at y equals 1. So if you just guess that that's true, you state that, you get a point. Y equals 1. And in fact, that is the case. The reason it is the case is that if you reflect a function over the line y equals x, you reflect every property of the function over the line y equals x, including the asymptote. And if you reflect the vertical line x equals 1 over the line y equals x, you get the line y equals 1. So that's another reason why that's the asymptote. And they just said state the equation. So that's full credit. Now, we are at the very last problem of the Regents. And in fact, if you look at the Regents score, we're 6 points away from a perfect grade. We have a 94 right now. We have a 94, which is a phenomenal grade. I want to, before we get to the end of the question, because when we get to the end of the question, I'm basically going to end the video and I'm going to stop. But I do want to, one more time, I want to ask you, if you're at this point of the video, I feel like I've earned your subscription, and I do appreciate it if you would subscribe. That does help me out tremendously. Only though, only if you feel that I've earned your subscription. Okay. Um, Now about you, listen, you've gotten through all the way to this point, which means that you're willing to make the effort. I know that you can do it. If the test is tomorrow, what I would recommend is, if you did try the problems on your own, and then I would say any questions that you got wrong, redo those and then see if you got them right. The other thing is, like, if you just don't wanted to do it by taking notes, you can copy down exactly the way I do it, and that does help a little bit with the muscle memory. It's not a perfect thing, but it does help tremendously. And if you do copy down everything I do, you can expect maybe 10 points more on tomorrow's Regents. So, but do what you do. I know you can do it. I know you have the capacity. Just put in that effort, bring in your snacks, and show all work on the part ones also, even though they're not going to see it, and then show your work on the part twos, threes, and fours, and you will get the best grade that you absolutely can. And don't skip any questions that you can't complete fully. Any questions that you can't complete fully, you just literally start them if you're able to start them, because you can find partial credit everywhere on this test. You just have to get to a final answer. You just start them, and even if you have to, there's a part that you're not sure of, but you have to do something. Just do something. Get an answer. That error will be maybe 1 point off, and that's half a multiple choice. Every time you make an error, that's just half a multiple choice. But it's also half a multiple choice that you gain in points. Get to a final answer, and get your points. You earned them. They're yours. Do it. I want to point out here that this question is worth 6 credits. That's equal to 3 multiple choice. It says clearly indicate all the necessary steps. You got to indicate the necessary steps, formula substitutions. You got to show all your work. Utilize all the information provided, all, and I'm going to cross out the not necessarily drawn to scale, and I'm going to put almost. As you know, I'm going to put almost always. So, and a correct numerical answer with no work shown will receive 1 credit. So if you get the numerical answer on your calculator, that's a point. Okay. So, número 37, final question, number 37. Megan is performing an experiment in a lab where the air temperature is a constant 73 degrees Fahrenheit and the liquid is 237 degrees Fahrenheit. 1.5 hours later, the temperature of the liquid is 112 Fahrenheit. Newton's law of cooling states that T of T is equal to T sub A plus capital T of little t. Okay, so let me read the equation again. Capital T of little t equals capital T of sub A plus capital T sub 0 minus capital T sub A times e to the negative kt, where capital T of T is equal to the temperature, F, in degrees Fahrenheit of the liquid at T hours. So it's a variable, it changes. T sub A is equal to the air temperature. Capital T sub 0 is equal to the initial temperature of the liquid, and K is equal to a constant, some mystery constant. Determine the value of K to the nearest thousand. So little t, in this problem, the information that they gave us information about a fixed time, 1.5 hours later. T, remember, T is equal to the time in hours. 1.5 hours later, that means T is equal to 1.5. And at that time, the temperature of the liquid is equal to 112. They did say also that the air temperature is 73. The air temperature, T sub A, is equal to 73. Okay? What else did they say? The initial temperature of the liquid is equal to 237. This is all in degrees Fahrenheit. We have to verify that they gave us those numbers in those units, degrees Fahrenheit, okay? And time in hours, okay. So now all of these numbers in the equation, T of T, T sub A, T sub 0, T sub A, and negative K, K is just the only number that's missing. So we can solve for it. It might look ugly, but let's put it in. So we got T of 1.5 is 112 is equal to T of A, 73, T sub A, 73, plus T sub 0, which is 237, minus T sub A, which is 73, times e to the negative k times 1.5. I'm going to solve. I might feel like I don't know how to do this problem, but the truth is that if I just go ahead and start doing arithmetic, I can get the answer. Minus 73. That's 73. T, after all, k appears exactly once in the problem. I could actually do this via the inverse operation method. And I get 39 is equal to, I go to my calculator, 237 minus 73. I don't do that in my head. I got 164 e to the negative k times 1.5. Divide by 164. Divide by 164. I got that e to the negative k times 1.5 is equal to, it's funny that the previous problem had a 1.5 in there too, equals to 39 over 164. And the answer for that number was actually also close to 1, but slightly less. It's weird, just coincidence. So how did I get the exponent out? I got use the ln. ln of 39 over 164 is equal to ln of e to the negative k times 1.5. The exponent comes out. Or equivalently, you could say that the ln is the inverse function of the exponential function with base e. And so on the right side, you get negative k times 1.5 is equal to 39 over 64, 164. All of that divided by negative 1.5, divided by negative 1.5. And as you know, I'm an enemy of PEMDAS. My favorite is GEDMSA as an acronym for PEMDAS, because PEMDAS is a 4-step process, not a 6-step process. GEDMSA could be a 6-step process, which actually, if you learn, can be simplified further, as opposed to PEMDAS, which is just complicated from moment one, and for no reason. It violates a lot of the ways we format math. Anyway, so 39 over 164 divided by negative 1.5. I go to my calculator, 39 divided by, in parentheses, 39 divided by 164. Close parentheses. Let's get that big LCD in there. Close that parentheses, divided by negative 1.5. And as you know, what I recommend. What did I mess up? I lost the ln. I lost the ln. I lost the ln. It's gone. Oh my god. Let's put it back in. If you got confused, where'd my ln go? It just disappeared. ln of 39 over 164. I might be so excited about this video being almost over. Divided by negative 1.5. Close. And I bring that, because as you know, I recommend writing the full decimal, and then rounding to what they said. K is approximately equal to 0.9575365211, which is approximately, now I go back to the thing that they said, to the nearest thousandth, 0.95, that's a 5 or above. I round up. So 958. Okay? That's 2 points. Dos puntos. For sure. All right, number 37, part 2. Determine the temperature of the liquid using your value of K to the nearest degree after 2.5 hours. Well, I'm going to do my quick estimate. If the liquid started at 237 and now is at 112, that's more than halfway towards the 73. So my estimate is going to be more than halfway. Well, but now it's only 1 hour more. It might be about halfway to 73, but maybe closer. Let me make a more refined estimate. This is way more than halfway to 73. It's actually 3/4 of the way to 73. According to 39 over 164 is more than 3/4 of the way to 73. So after an hour, it's going to be more than a half, halfway to 73. So 112 to 73. So my estimate might be in the high 80s. My estimate for the second one. So if I don't get something like in the high 80s or something close to that, then I think I might have done something. Okay, so I'm using that value of k, using your value of k. So now we're not using the full decimal because they said using our value of k. What look, and I want to point out the benefit of that. If you made an error on part one, or you didn't even know how to do it, if you just gave a value of k, as crazy as it is for part one, and you use that value of k for part two, you could still get full credit for that second half, which is a full multiple choice question. Let's say you said, I don't know how to do this part. I'm going to let k be 0.8 or 0.5 or 2 or 7. Then you could have used that number to get a value of the temperature, and you would have gotten full credit for the second half, for the second third. Okay, so T of 2.5 is equal to, according to them, 73 plus 237 minus 73 times e to the negative 0.958 times the number of hours is now 2.5. And so I go to my calculator. I go to my calculator and plug this number in. I do want to tell you where the E is, so I guess I should plug it in the long way, because I know a lot of students forget where E is. So 73 plus 237 minus 73 times E to the negative. So E was above the LN button, next to the 4, above the LN button in blue. So I press the blue second button, press E. E to the point 0.958 times 2.5. Enter. And I missed the negative sign. Second entry. Negative. And as you know, I like writing the whole thing. It's my best piece of advice that I could give you because it's a muscle memory fixer. The difference between what I would teach and what I tutor is this. When I teach you, I could say something over and over and over. I could teach you to look for the instructions. But when I tutor you, you're looking at this video once, or if I'm meeting you, I'm meeting you exactly once. So, or more times, but I get to speak about this specific thing once. So I don't necessarily get to teach you how to do something. I get to fix. And that's actually one of the things that makes me kind of a goat with tutoring. And if you ask around, one of the reasons I could charge what I charge is literally like I take students who get 60s and turn them into 80 or 90 students in like 3 sessions. And that's not even rare for me. I take students who've gotten 20s on the ACTs and gotten them to 30s, 32, 33. Now, when I say 20s, I mean like 22. And I turn that into a 33 or 35. Doesn't even have, it's not even rare for me. So one of the things, the tricks that I'm teaching you are extremely helpful. They might not seem extremely helpful, but they actually are. Here, I get 87.95231934. Now they said to the nearest degree. This should be an approximately symbol. So approximately 88. That is also again a muscle memory fixture. Now for the very last part, and I want to just congratulate you for being here at the last part and for having made it all the way through this point. I do want to thank you for watching this video. I'm going to thank you again at this. And listen, I know you could do it. I want you to just go gung ho and do everything that you need to do to get the score that you want. Let's finish this part and then we'll say goodbye to each other. And if you need to watch this video again, do watch it again. Write down everything that I do, everything that you got wrong, especially on the questions that you struggle with most. Write down what I do. Let that muscle memory sink in for you for tomorrow. Okay. The last part, Megan needs the temperature of the liquid to be 80 degrees to perform the next step in her experiment. Use your value of k to determine to the nearest tenth of an hour how much time she must wait since she first began her experiment. So we're looking from time t equals 0. She's already at 88 and the temperature is cooling very fast. I think it's going to be less than an hour. That's my estimate because we're about halfway between 88 and 73. And it's cooling by more than halfway per hour. So a little less than an hour from 2.5 hours, a little less than 3.5 hours. I don't know. 3.3 hours. Let's see. T of T. Now we're looking for T again. So this is equal to 80, and this is equal to 73 plus 237 minus 73 e to the negative 0.958 t. So same process that we used to solve before, minus 73, minus 73. We got 7 is equal to, now if you remember, we already got 237 minus 73. We could put it in 164 e to the negative 0.958 t, divide by 164, divide by 164, we got that 7 over 164 is equal to e to the negative 0.958 t. Take the ln of both sides. And we are almost done. Look at this. Last bits of writing. E to the, sorry, no more e. Negative 0.958 t equals, now you can put this into the calculator and get those decimals out now, but I prefer to put it into the calculator at the end. Divide by negative 0.958, divide by negative 0.958. If I don't get something around 3.3, I know that I did this wrong. A little less than 3.5. 2.5 hours plus an hour is 3.5 hours. A little less than 3.5 hours is 3.3 hours, 3.2, 3.4. Those are valid guesses. T approximately equal to, now we go to our calculator. Now ln of that number is ln of a number less than 1. That should be negative, so at least the sign of the number makes sense. Negative ln, nope, ln of 7 over 164, close parentheses, that's a negative number, divided by negative 0.958. Okay, so 3.292229936, and t is approximately equal to, then we go back to the problem, tenth of an hour, and look at that, what I had said. That was my estimate, 3.3. And with that, we just got 100 on the June 2024 Algebra 2 Regents. Listen, I wanna say thank you for sticking with the video for as long as you did. If you stuck to this video as long as you did, I am fully confident that you're gonna do great on this test tomorrow. If you didn't do any amount of writing, any amount of work, you didn't try the problems on your own, you just literally just watched me, what I advise you to do, the best thing for you to do tomorrow, I mean, the best thing for you to do between today and tomorrow, and or what today and whenever the test is, really to do the problems on your own and see how I did it and then correct your errors. But if you're not going to do that, the next best thing that you could do is literally write down every single thing that I wrote down to solve every problem. You don't have to write the notes that I took, but actually some of the times when I gave a definition, writing that down actually helps. It's actually a phenomenal muscle memory tool to write down the exact solution to problems that can appear on the test. So my recommendation for you between now and tomorrow, or between now and the Regents, again, my best recommendation is just to do the problems. But my second best recommendation is to write down every single thing that I wrote down, and you will do phenomenally on this. And I want to just say congrats for being an amazing, awesome individual. Thank you for watching. And please do subscribe if you feel like I've earned it. And I will see you in the next video. Bye bye.